Hello everyone. Welcome to Azure AI Connect 2025. This is stream 1 and we have Radu uh, Vunvulea with us. If I am pronouncing the name wrong, Vunvulea, yes. Please forgive me, Radu. He's going to explain everything about the reference architecture of AI in the cloud. Um, If I understand correctly, this is a very needed session. Let me add Radu on the screen and he can explain more about this. Hello, my friend.
Hi guys, nice meeting you.
Thank you so much, Radu, for being with us. We are so
Thanks for having.
grateful that we can have you present on Azure AI Connect 2025. You're calling from Romania, is that correct?
Yes, I'm from the middle of Transylvania, the heart of Transylvania, a Cluj, called Cluj, city called Cluj, Cluj-Napoca.
Perfect. Perfect. I am always wanted to visit Romania, and actually, I have a friend there working in OCI. So, again, thank you so much for being with us. I'm adding your screen to the stage and I'm going to be on the background. Everyone, Radu is driving. Thank you so much, my friends.
Hello, everybody. Thank you for inviting me here. Thank you for having me here. Thank you for you as an attendee for making time and giving 50 minutes of your time on this session. Nice meeting you all. In today's session, we'll talk about reference architecture of an AI in the cloud. And the main purpose is not to focus on the AI component, on the AI service, but to understand the landscape. What is around the AI functionality that we want to add to an existing system to ensure that that system will work as expected. That system will be able to handle the payload, the load that is created by AI, because otherwise we can end up in situations where we create bottlenecks because an API from the system that is used by AI component cannot scale enough. The same thing could happen with the database. We don't have the right security and identity access management level, and we end up in situation where everybody can access any kind of information that we are adding to that vector database and many more. So this is what we would like to tackle today. Something that I found interesting, at least what happened at the beginning of this year, and these are the good news, is that OpenAI is boosting, and we know that is already pushing a lot of innovation in this space, especially in the Microsoft ecosystem, and they're looking to dedicated uh, data centers like SoftBank that will be built for AI capabilities, meaning computation, storage that is built in such a way to be able to handle this kind of things. Who am I? I'm Radu Vunvulea. I'm VP of Cloud in Endava, also Microsoft Azure MVP for a pretty long time, and Microsoft Regional Director. If you want to have a chat with me about Azure, about cloud, about coffee, drop me a message on LinkedIn, and I will be more than happy to connect and to have a virtual or maybe a physical coffee together with you. Next week, I will be at CloudFest in Germany. So if you join CloudFest, just throw me a line and let's meet in person. So our mission is the following: identify what is the cloud architecture of an AI system? What we need to consider. You will see that I will give some examples from Microsoft, from Azure World, but keep in mind that the same service mapping, similar services exist in all other cloud vendors like AWS, or Google Cloud. I don't think that there's enough time, space, and you already been bombarded by a lot of information about how cool is AI, how it will change the world. We already know that we are living now some changes that are pushed behind the AI, and I would say that will change the way how we work, do our day-to-day business, and in the end, maybe even how we live and the way how we live. Why AI is so complex, and why I think that we need to consider AI and how AI become part of our ecosystem that we are building on top of a cloud vendor like Azure, is because this is just a part of the services that are available under AI and ML in Azure. There are many other more. We are now in the moment in time when it's not only ML Studio or OpenAI. You need also to consider out of the shared services and based on the business needs, based on the things that you want to achieve, to identify exactly what is the best service, what is the best option for your current context. Also, there are two main services that people are exploring when they're looking to build and to do and to integrate AI in existing business, in existing systems. We're talking about open AI and machine learning. I will not go too deep in both of them, but what I want to highlight is that open AI is for when you want to build an NLP or something like a GPT to be able to get the data, use a pre-trained model to solve a specific need. Meaning that you can use the current people that you have in your team, developers, DevOps, infrastructure people, and so on, versus Azure Machine Learning and the Studio is when you want to do some customization, you want to take a pre-trained model and to train specific to your own needs. When you go with Machine Learning Studio, it's more than development, it's more than DevOps, infrastructure, and so on. You need dedicated people with skills that are regarding to data science, to know very well the models. You need to go on the MLOps and auto ML parts and so on. And what both have in common, in both cases, you are adding a new system that needs to communicate with all the platform, with all the services in the platform that you already built. And you need to ensure that he can work as expected, he has the access, he has the bandwidth, and so on. And this is something that at this moment in time, companies don't consider enough or don't they take into account. They expect that we just take the ML or the OpenAI component, putting in our existing system, and all done. We are happy. No other investment required except that model that you need to put there. So, what's next? What is our agenda? We will identify why and what is the impact. We'll take a look on the services that are more relevant and we need to consider in the modernization exercise to have an AI ready solution. We'll then look about on a landscape and we'll point out the complexity of it, and then in the end we'll try to cover an existing modernization exercise with all the steps that needs to be done to ensure that e-commerce application is ready to ingest, to use, and to manage an AI component. Going forward, what are the challenges and what are the limitations that come with AI when we use also cloud? I would say that one of the biggest problems that we need to consider and we need to take into account that there are a lot of systems that were migrated from on-prem or built from scratch. In the last 2 4 years, many of them were in a lift and shift manner or in an approach where they don't use one full native cloud components. And the second one is that even if the lifecycle of the system is 5 or 6 years, they are still using the same services, the same approach of 4 or 5 years ago. Meaning that there are some components, there are some parts of them that cannot scale enough or cannot respond to the needs of an AI system. Now, if we put on top of that also AI, that comes automatically with challenges regarding data privacy and security, the ethical consideration, complexity and technical limitation, the human workforce and the job displacement, and legal and regulatory challenges. I would like to highlight the one that's more technical, more specific to us. Sensitivity of data is very, very important, and the way how we approach it, we need to ensure that we have a data governance layer that can know exactly, based on a data catalog, what kind of data you have, where it is stored, who owns it, how it is represented, and so on. Having a data catalog is not cheap. And this is what I want to highlight, because before starting to use AI, you need to understand what kind of data you have. Data catalog is one of the initial things that you need to add, but comes with a lot of costs. Data volume, it's another thing. It is the same story that we had, for example, in 2020 and 2021, when everybody was trying to do analytics, extracting value from their data, but they were still using the same approach of storing the data as 3 or 4 years ago, and putting on top on analytic systems was struggling, was almost killing the computation power and the ability to execute queries and also to run business at the same time. Resource intensiveness is also very important, because when you add that AI component, is not only impact the payload and the workload that you need for the AI component. No, all the system that would communicate by a trigger from the AI or would fetch data to your AI component would have an increased payload. And you need to respond to a simple question: are that systems ready to be able to handle this? Are able to scale up and down automatically? Do you have auto scaling in place and in the right mechanism, or it's just based on some KPIs, based on some metrics that you've done a pilot initially and everything went well and you didn't do any kind of changes? Data transfer, it's another thing. It's very important, because you might have the data in multiple locations, in different silos. And if you put the AI system might run in only one region, in only one location. And then you need to think about building a lake or providing access to that silos. But can you move all the data? Do you need to do any kind of actions? What kind of restrictions are? And again, the data catalog is one of the first things that you need to consider, to take into account. We saw what are the challenges. Let's take a look, based on these challenges, what are the most 5 areas of modernization, the ones that are the most important and the most relevant, that would bring value to the AI solution that you would build on top of that. We talk about scalability and performance bottlenecks. You need to overcome the AI data silos and the governance challenge. You need to find the right balance between innovation and compliancy, how you manage the cost of AI without killing the performance, and why some AI models might fail in a cloud deployment. What I would like to cover and to talk about, it is about performance uh, bottlenecks, because one is the AI and the rest of the system. If you are using the same components, the same services for the business streams and also for the AI component, then you need to ensure that you scale up exactly based on the business needs plus the AI components, or you disconnect and you have two separate streams that scale independently based on this. Because otherwise, you can end up that you see some performance degradation, not in your business, but in your AI business flows. And they are generated because you do some API calls from the AI components to some other component that takes 1 to 5 seconds to be able to give a response. Or that asynchron call is too slow, or maybe you don't have the right approach because maybe the other approach is more an event-driven architecture. Another thing that I want to highlight here is the right balance between innovation and compliancy. Because when you go too much in one direction or in another, if you go too much on the compliancy and you become very, very strict, then the innovation, the new thing that you want to add, to try, or the business team would like to explore, become more hard to do, more hard to be able to take any kind of actions. Versus if you are more on the innovation path, then you lack of compliancy, lack of the governance framework, and then you can end up very easily not meeting the local regulatory compliancy, or you end up in situation when you are exposed from the security point of view to different vulnerabilities and so on. So you need to find the right balance between these two. What I want to highlight regarding MLOps, just one thing, is that DevOps is not MLOps. The way how you approach them is fully different. Yes, both of them have ops at the end, but you need to ensure that you have the right people with the right skill that would define uh, the right pipelines that you're looking for. Going forward to the third topic, it is what are the key of success? What you need to do to ensure that you're doing uh, and you take the right decisions on your existing platform to be able to use with success AI and also to respond to your current customer needs. When you take this into account, is that it's not only about AI. You need to run fully on cloud modernization exercise to ensure that everything is in place, from efficiency to scalability to modernization. And when I say here modernization, what I'm thinking about is using the right cloud services and the right cloud architecture that is aligned with business and industry that you're part of. Also, you need to ensure that you have a very good FinOp component. Basically, you can track the cost, you can track the consumption, and you do a full governance of it. And you can react in real time or near real time to any kind of changes that are happening there. If you expect that in an existing system, you just add something related to AI, and once people will start to use it, it will be a big success. No, you need to ensure that also all the environment around it It's ready to be able to handle that that kind of load. There's technically, I think that we have the right frameworks. We have, for example, cloud adoption framework. We have the best practices from each cloud vendor. There's a lot of documentation. What is harder is to ensure that in the AI modernization exercise or in the AI exercise to bring AI to existing systems, you secure time, effort, and the budget to do also the modernization, and the stakeholders would understand why modernization is so valuable for them. The first thing for a success AI story is performance and scalability. You need to ensure that AI workloads, first of all, can scale up and down. And also, all the other systems that are connected with AI workloads have the ability to scale statically, dynamically, based on standard metrics or based on some or based on the payload of the size of AI workload. But you need to end up in in a system that can fully scale up. And yes, this is true that automatically when you add some AI workloads, also the cost of the current infrastructure will go up. The second thing is about data integration and management. If you have multiple silos where you store the data, don't expect that you will be able to have a big success with a new AI system because you need one central location or a reduced number of central location. Now, depends on the business, how the business look like, where is your physical presence around the globe. But in the end, you need a lake, a warehouse, where all the data is stored, available. You have the data catalog, you have data security access, and so on, in such a way that when AI is starting to consume the data, he will go in only one location. This will influence how fast, how how the data can be accessed, and also who can access what. You might, if you already have a warehouse or a data lake solution, you might just need to scale up a little bit and ensure that you have all the other things to be able to have success. If not, a data platform that is unified would need to be required to be part of this AI journey. The third thing is about agility and flexibility. And what does this mean? Is that you need to ensure that you are providing to the team the capability to play with the solution. They have the capability to deploy easily the AI components, the MLOps, but also all the other services that are around it. So you need to start from the ground to ensure that you have the pipelines, multiple environments that can be created for all the system, and then you have also the pipeline of your AI components that can be used by your team. In the end, in the end, the team needs to be able to release something for testing in a pre-production dev test environment without any kind of issue. They should be they should have the agility level uh, at that level when they can decide, of course, if the budget exists and if they are approved, to spin up a new environment automatically, to test a new model, and then to shut down and to clean everything without having to do more than one or two clicks on a dashboard. No additional code, just some approvals from the governance layer, but nothing more than that. The fourth thing is about tooling. And I'm very happy. And why? Because I was looking at AI related tools for the full development ecosystem, for how you manage, how you collect metrics and logs of the AI services and so on in 2024 at the beginning. And 1 year ago, we were in a position where I said that, there's a lot of space of improvement. We don't have yet the tools that are required to have a good end-to-end experience. Now, in 2025, uh, I'm in a position where I can say that the tools that are around AI ecosystem start to have a good maturity level that is allowing us to focus more on the outcomes, on the business uh, scope, and to use pre-existing tools that can help us to build, to run, to monitor, and to understand the output, the output of an AI component, how it is interacting, how we are managing access and control, and so on. And a good example here is, for example, if you take a look on Confluence and at the Atlassian products and to Microsoft 365, both of them now give you the capability to integrate an AI assistant, something like ChatGPT or Copilot, and a user can search, can play around only with data that he has access based on his role, based on the user, and so on. You don't need to manage this by yourself. What other things are around here? We talk about cost efficiency, security and compliance, interoperability, and real-time analytics. And two things that I want to highlight here. First of all, is the operational part that we don't need to forget. Once we add an AI component, an AI service, we need to ensure that also we can, in near real time, to monitor and to have insights about that AI service. What kind of data it access, what are the current points and metrics and all the other things around it. We need to treat it as another component of the system, and we need to be able to know exactly what is doing, what is the current state, to be able to collect all the security audits and so on. And the second thing is about cost. And now I'm referring to running a solution. And we need to ensure that we have the capability to understand and to track what are the costs, to understand what is the expected cost, what are the thresholds when we need to react, and also if the system interacts through triggers, through events with other parts of our system, we need to ensure that we have an architectural approach, and here an example is a serverless architecture that would optimize our running costs. Okay, going forward, what are the key of AI modernization of cloud services? And as I said at the beginning, I would like to give some examples about what is the service, what is the problem that we solve through that service if we are planning to integrate an AI solution, how and what are the benefits. One of the computation services that I think that is very important is Azure Kubernetes Service or another flavor of Kubernetes or something similar. And why? It is important to be able to have a system that can scale, that can allocate resources based on the type of computation needs that we have. For example, you can run in the same cluster. Let's say that we have a cluster with 100 or 150 machines, where you can have nodes that are dedicated for normal CPU utilizations. Others are dedicated with GPU power to run your AI model, and then you can do the orchestration on top of it to ensure that depending on the payload that you run, they end up in the right nodes. So you in the end you end up with a system that avoid more or less bottlenecks and can scale based on specific needs. And it's pretty easy. You end up in a mechanism that can manage it without any kind of problem. When we work with AI, we end up in two positions. So the first one, we need to ensure that we can run with success event-driven actions, event-driven activities, because many times the AI component would trigger different different actions, and you need an efficient way how you can scale up, how you can execute them. Sometimes you look at real time, and then you want to have some reserved computation power to be able to handle that. In other situations, we're talking about cases when if it trigger an action in 1 or 2 or 5 seconds delay from the business, there's not too much impact. So if you go in an event-driven approach that goes very well with AI workloads, then you need a serverless approach like Azure Functions to be able to execute that payload. Or if you have an external call that is triggered by the AI, then the same thing, an Azure function will be able to do that. And also, the dynamic scaling enable you to achieve the things that you're looking. Of course, there are some situations where even if you use, for example, Azure Function, you would need a dedicated environment because of some regulatory and compliance requirements. But otherwise, you can fully use the functionality that comes with the serverless approach. Another big problem that we need to tackle is data silos. And in the end, how we make available all the data that is required to train and to run your models or and your AI components. You need to ensure that you make the data available, ready to be used, and as close as possible also to that AI components. Plus, beside this, you need to do the data governance, you need the data catalog, and so on. So you need a strategy where you have that lake in place that native can work with AI, with AI services. A good example here is Microsoft Fabric. And why? First of all, I would say it's one of the most uh, easy to use and performant lake approach that you can have on Azure. And beside this, also provides a seamless integration with defining a pipeline, exposing your data to different AI systems, the full integration that has with with Pureview or other data catalog solution. You end up in an approach where you have one service that store, manage, and control and expose the data that you have across your organization that is centralized in one place. Something that we are forgetting, and we forget about it, is how we expose that AI capability. Most of the time, we're exposing through an API. So We need a layer 4, layer 7, like Azure Application Gateway, that would manage and would offer us a protection of our API. We don't want to manage that by ourselves. So we need and we want to prevent attacks of our API, to prevent cross-site scripting, to optimize the traffic to be able to redirect in other locations. So a good starting point is having an approach together with Azure Application Gateway, and on top of that, you also might need versioning control and so on. But in the end, as you can see, you already need all the layers of a system that would a classical, let's say, REST API solution. It's not only about the AI component. Nowadays, if you want to do real-time capabilities from data processing to react to changes and so on, you need an efficient way how your data stream can end up in your AI components. Because of this, you need an event stream, then you need to rely on Azure Event Hub or similar solutions that can fetch a high number of events and can ensure that they end up to different parties. Can be to Microsoft Fabric, can be to Microsoft Fabric and to your AI to your AI solution and so on. For example, if you're monitoring devices that are on-prem and create different stream of events, if you're in a financial system that is collecting data from multiple banks and you need to stream all this content in one location to be able to react to different changes or to take decisions, then you need different stream of events. We talk about data governance, and you need a way how you manage the data catalog, because you need to understand what kind of data you have, what is the consistency level, how you comply with different regulations, what kind of data can be exposed to different parties, to different systems, and so on. Azure Purview is providing a unified way how you do the data catalog, the data governance, and how you can decide exactly what content you're pushing to the AI workloads. What I want to mention here, and I saw also in the past, is the following. All the solutions that are covering data governance and data catalogs are expensive. And this is why it is important to start the cloud modernization exercise at the same time when you start the exercise regarding AI and integrating AI, because there are some direct costs and in that indirect cost that comes, and you may end up in situation where, let's say that the cost of running AI services is 100K per month, and once you finish the modernization exercise to be able to be fully running scalable compliance with the AI part, you end up also with additional 50K per month. And in the end, that's something that the stakeholders needs to be aware of. And the last thing, FinOps. You need to ensure that you have the ability to track, control, understand, and react to changes in your cloud cost. So you need to ensure that you implement and you run with success the FinOps principles. I'm not aware of one tool that can manage everything, because more or less we have three important categories when we talk about FinOps: governance, cost optimization, and strategic alignment. But there are different services depending on the cloud vendor, depending on the technology stack that you go with, where you can use cost management, Azure Monitor, Azure Automation, Azure Advisor, and so on to be able to track and to do optimization. And there are some very basic tools that don't come with too much cost, like for example Azure Advisor that can provide very good recommendations of what are the actions, what are the activities that you need to do to be able to reduce the costs. Now, I really like this diagram. It is a diagram that you will find on Microsoft website. And what we can see here, and what I would like to highlight, is the following. From all these components, if you take a look, the AI component is Azure OpenAI Service and some other AI services. On top of that, we have a full set of other services, Azure services that needs to be added in place to ensure that you are well integrated the AI components to your current landscape. You can We need to treat integration of an AI functionality inside an existing system as we have a project inside the program. And yes, beside the work that will be done related to for OpenAI or for other AI services, there are others work that needs to be done, other services that needs to start to run, like Azure API management for the API gateway. You need an API, so you need a REST API that needs to be hosted somewhere. Then you need an identity management system. You need to ensure that you have the right identity, the right roles, and so on, configured in the right way. You will have some secrets, so you need a vault to be able to keep all the secrets. You need to connect to the rest of the network, so you need to have a private link or something similar. So you end up with more than just the AI service. Then you need storage, you need monitoring, you need you need a cost management solution, and so on. And besides this, because this is just how you do the integration, it's also everything else that we talk about: scalability, about the data governance, about data lake, and so on. So let's take a look how we can do, and let's take a look on a simplified approach of a modernization for a system that will use AI. Let's take a basic e-commerce platform that is built for a monolith that has a monolithic architecture, runs on on-prem, was migrated more or less in a lift and shift approach. On cloud, it's running with success. Stakeholders are happy, and now they want to have the AI component. So, what we need to do before deciding to use AI, we need to break down that monolithic application into microservices to have and to gain the scalability. We need to analyze the data and to ensure that the data storage solution that is used can scale and can face and manage the workload that AI would generate. We need to ensure that we have a CI/CD pipeline from the DevOps point of view. We can do automatically deployments and so on. And then we can take a look on how we integrate it. So, what does this mean? We start with breaking that monolithic to a microservice approach. We could use Docker, we could use AKS, and so on. Then we do a data modernization exercise to ensure that we have a unified uh, lake solution on top of it. We take a look on the DevOps practices and we ensure that we can build automatically an environment. We have the pipelines, maybe we have the DORA metrics and so on. Then we integrate the AI capabilities It's not only Azure ML and Azure API and OpenAI. We could use, for example, Azure Databricks or anything else that we would prefer. And then an important step is regarding monitoring and management, not only of the existing solution, but also to the AI component that we are adding in that landscape. And of course, when we do this integration, it's not only the AI services, it's also about all the other services that are required to be able to run with success that AI functionality. So let's resume what we covered in today's session. To be able to have success and to integrate an AI functionality to an existing system, we need to take a look on cloud native architecture. At this moment in time, serverless and containerization are very important, and also have a cloud native approach. We need to ensure that we do the data modernization, and more or less we have a data lake with a full government framework on top of it. We have the capability of building from scratch automatically an environment, and we have the right pipelines. Of course, we are using pre-built AI. We use pre-built AI services. We have in place the Azure policies, the security components regarding who access what, and also not the last thing that I think is very important. We have a robust monitoring system that allow us to scale up and down, and also we have a load balancer and traffic manager and the API management that would allow us to handle and to react to any kind of changes that are happening to our system. What are my final thoughts? Is that applications, greenfield applications that use AI are built day by day. But also there is a lot of existing applications that needs to integrate AI components. And to be able to do that, we need to ensure that more or less we do the cloud modernization as each cloud vendor is specified for the specific components and business that we are using. And as for example, we have a life cycle of different systems, different application, 3 or 5 years, and so on. Also, we need to consider what is the life cycle of an cloud infrastructure architecture and how often we need to review it. And before integrating AI, it is a good moment in time when we need or we can review the current landscape of our system and do the modernization to ensure that our system is ready to face the workloads and the needs that an AI system would generate. Thank you. Thank you for having me today. If you have any kind of question, I think that we might have some time now. Otherwise, you can reach me on LinkedIn, or maybe if you join CloudFest next week in Germany, let's enjoy a real coffee together. Thank you and have a great day.
Thank you, Radu. Uh, what an amazing presentation. I don't know if we have any questions from our audience. I don't see anything for now, but can you put up the card with your contact if you have it somewhere easy, just for a few seconds to be able to see it?
If you just Bing it on Google on Bing, my name, or on LinkedIn, you will find easily my profile.
Perfect. Okay, there was some requests to share the PowerPoints. I will link you on LinkedIn, and if you can share it, I will add the link to the chat of the YouTube. This is optional, and we're not forcing you to do it. But
Yes.
some more of the attendees have asked for a presentation. I want to thank you, Radu, for being here with us today. Uh, Excellent presentation, excellent content. We will definitely look for you again in another event of ours. We are so grateful you can come with us and deliver it. Have a great day, my friend, and thank you again. Thank you for everything.
Thank you. Thank you for the invitation and have a great day.
Bye bye.
Bye bye.
Great. Okay, Radu has concluded. We are waiting for our next speaker, being Jonathan Harel. I don't know if he's here. I believe he's not yet here. So for a moment, I will play a video. We have also our moderator here, and in case our speaker jumps in, he will help with adding him on the stream. Uh, okay, let me add the video. Have a small break, and we will be right back when our speaker is here. Thank you very much. Hello, Bill. Welcome to Azure AI Connect 2025. I'm sorry we had you waiting. Welcome, and we are very glad to have you with us. And let me explain what we are going to tell us. We're going to describe from chatbot to goal-oriented AI agent using semantic kernel. Semantic Kernel is being a framework that helps so many people deliver their applications in an easier way than writing thousands of lines of code. And I think Bill is here to explain more about it. Thank you so much, Bill, for being with us. We are so grateful to have you. Are you ready to share your screen?
Actually, I think I was testing. I think I'm not on for 2 more hours.
Yeah, that's it.
Okay, so we're not live, right? It's just the two of us.
Yeah, you have added your screen, and I have shared it.
Okay, but we're not live, right? It's just the two of us.
Come again?
It's just you and I on this.
No, we have online viewers, but in this one we are me and you. But people are watching live right now.
But I'm not on for 2 more hours, I believe.
Okay.
So
Oh,
I was just testing.
going to
I'm
work.
sorry
Okay, no problem. No
if I
problem.
interrupted.
No problem.
I'll come back in 2 hours.
Okay.
Hey,
Yeah, I'm sorry for the mix-up. We have Jonathan with us, and he in correct order. To tell you the truth, I'm sorry, Jonathan. We thought that you were not coming. Thank you so much for being here with us today. Your session is about the rise of AI agents. Yeah, we're going to have AI agents
hello, hello.
everywhere, and this is the reality of it. We are so happy to have you with us and so grateful that you are able to present here. I see Naveen also our operator. Hi, Naveen, how are you? And yeah, Jonathan, if you want to present your screen, I will add it on the stage.
Sure thing. So thank you for having me. I'll share my slides and let me know when to begin.
Yes, you can add your screen, so you can add it on the stage, and you are ready to go.
Okay.
I'm taking myself
Okay.
out
Can you
as
see?
Naveen is sitting there.
All right. Can we see the screen? Everything's okay?
Yes, we are able to see your screen, Jonathan. Go on, the stage is yours, my
Perfect. Thank
friend.
you. Amazing. So hello guys, and I'm very happy to be here. My name is Jonathan. I'm the VP R&D and co-founder of Fine. If you've heard of us or maybe not, what we are doing at Fine is basically we are using AI agents to build software. So I'm telling you this because I've been dealing with AI agents pretty much for the past 2 years, really with every cutting edge tool that has to do with agents, with AI, with LLMs that anybody released out there, open source, closed source, all of those. And I've seen the improvement that AI agents have gone through and the process that we've gone through in using them. And it's really interesting and exciting and exponential, I should say. And I'd love to share a bit about that with you. So this talk is called The Rise of AI Agents. But so feel free to ask any question. And I'm sure that if you are here, you already heard about the term AI agent, but we will explain everything about this shortly. Okay, so before we dive into the world of AI agents, we should probably talk a little bit about the first part, about AI and what was the history and the process that brought us to work with agents. So, back in 2012, 2016, something like this, when companies talked about, yeah, we have AI in our product, we are doing AI this, AI that, most of the time it was something like cat versus dog, right? Or if you saw maybe something a bit more intelligent, like recognizing cancer in biopsies,
or if you saw the Silicon Valley shows, then maybe hot dog or not hot dog. But AI used to be a specialist, right? We thought of AI as some kind of model that specializes in one very specific field. This is the one thing that it can do. It can separate between A and B. Maybe it can predict something with some probability, but it knows this one thing and knows one thing very well. Now, this was very much the approach that we also took to working with AI, and this is why it was very difficult to work with AI for code. For example, development is very different than backend development, not to talk about embedded or low-level development, totally different fields, even though all of them are developers. Now, this perception, or this started to shift a little bit in 2018 when Google released BERT. So I don't know how many of you remember this name, but it was a large language model at the time. Today we will look at it and we will say, it's a pretty tiny model. But BERT was the first language model that you looked at the outputs and you said, this is a bit different. There's a model here that can actually makes sense. It seems like it understands deeper meanings. It understands deeper connections. We can have a conversation with it. It was the model used for the auto-completions on Gmail, for example. But even though it showed signs of intelligence, it wasn't really until OpenAI released ChatGPT in 2021 where we had this boom of large language models and we understood the true potential of these models. And the reason that we suddenly had a turning point in AI is because we went from models that are very specific, very specialists, to generalist models. Now, when we are looking at the capabilities of ChatGPT, it's one model, but it can pass the bar exam. So it's acting like a lawyer, but it can also write rap like it was Shakespeare. And this is such a wide variety of skills that we started to believe, hey, you know what? This model is a generalist. It's a general AI, which was pretty amazing, and it was what we are working towards. So we have this turning point in using AI, in building with AI, in doing everything with AI, where we stop thinking about AI as a specialist and we start thinking about these large language models as generalists, as this general intelligence that can handle many, many things. But even though this is a generalist technology, generalist models, they are really smart, they are amazing at so many fields, we know, because we used ChatGPT, me and you, probably many times, that even though the results are promising, problems are very evident. What do I mean by that? So you probably had a few encounters more in the past with one of those chat models where you ask for something and you get a result that is pretty weird. Even though it feels like you're talking to a very intelligent person, sometimes the results are a bit surprisingly not human. For example, this is an interesting case where one user asked ChatGPT a few years ago, a few months ago, hey, can you recognize this? And I recognize this character, you recognize this character, and of course the model recognizes it as well. Yes, this is the famous ASCII art representation of the Mona Lisa. I hope that was not your answer. But what I want to point to here is that these models are very, very smart, and yet they are not smart enough, or they can't say, I don't know, which is something that we expect of intelligent people to say. And even worse, if you ask them a question that they don't know the answer, they might make up a response, but in a very convincing way. And this is very bad for us, for example, as coders, because if we look at some code and it looks very convincing and we just accept it and push to production, for example, we're going to have bugs in production, which might be very bad for, I don't know, the medical industry. So, of course, nobody actually crossed the English channel by foot. This is just made up information. So these models are eager to answer. They will answer wrong. And they also have some faults of logic. So if we look at this example, this is a classic riddle. If it takes 5 machines 5 minutes to make 5 devices, how long would it take 100 machines to make 100 devices? And the natural tendency of most listeners is to say, okay, if it's like 5, 5, 5, then it would be 100, 100, 100, as we can see in the second response of ChatGPT. And even though the user tries to guide the model towards the right answer, eventually the model didn't come up with the right response. So what I want to point to here is that although we speak to this smart, intelligent entity, it seems that it doesn't go through the same thinking process that we do. Of course, we know that it doesn't actually go through this thinking process because we apply some logic and stuff, but this is very evident in certain cases. It's less evident in other cases, so it might surprise us. And another problem that we have with these models, and this is a funny example. This guy asks the model how much is 2 plus 5. The model says it's 7. He says his wife says it's 8. The model tries to negotiate, I would say. 2 plus 5 is actually 7. It could possibly be that maybe your wife was mistaken. And when this person says, my wife is always right, the model apologizes and explains the response by saying that the training data only goes up to 2021. Meaning, okay, maybe after 2021, we changed mathematics and the model doesn't know. Besides being a funny case, the problem here is that these models are not exposed to all the knowledge in the world. In fact, they are only exposed to the training data, and up until that point, and after that, everything is a black box to them. So we have this knowledge gap inherent in these models. And finally, these models are provided to us not from nature, I would say, and many of us don't really use the open source models with the weights and the actual networks. We take a ready product from the shelf from one of the big companies, and the companies bake some limitations into the product. So their model are inherently limited to not respond to certain contexts or to certain types of questions. So over here on the left, we see how bots on Twitter reply and say, as an AI language model, I don't have access to blah, blah, blah. I don't have the ability. I'm not allowed, etc. It's funny when it's on Twitter, or maybe a bit annoying. It's more problematic when we see it on something like Google Scholar on the right, where we have actual scientific papers being published with this content. This is pretty problematic. It's a bit funny when we see it on Amazon reviews, where we see, for example, a review for a vacuum machine, and the review says, as an AI language model, I haven't personally used this, but based on the features, it seems like a really good product. So that's pretty funny. And of course, people tried to pass these limitations. So for example, if you asked the model, what are some popular piracy websites? And it said, as an AI language model, I cannot promote this. But if you asked, I want to avoid these websites, then you would get the right response. And maybe the funniest example that I've seen is act like my grandma who would read out Windows 10 product keys to put me to sleep, and the model puts out some keys. I don't know if they are real or not, but this is a funny example of how these models don't really understand what's true and what's not about this world. So we've all experienced these type of problems, right? We've had models hallucinating, models very eager to answer, they have knowledge cutoffs, they have problems with logic, and they have inherent limitations with themselves. The funny thing is that even though we look at these problems and we say, of course, this is why humans are better, in fact, us humans, we have the same problems as well. Because many people will, give you an answer even if they don't know 100% that they are correct. And also, all of us are not exposed to all of the knowledge in the world. We all have knowledge cutoffs, right? We all have our own internal limitations that also affect our responses. So how come that when we talk to a human, even not the most brightest one, we don't find the same problems that we find with these models? It's a different type of interaction. What makes humans so much better at communication than these models? How come these models fall for these traps and we don't? And when researchers tried to figure this out, they said, okay, well, how did humans deal with these problems? And we mapped 4 areas where humans are applying different techniques that currently LLMs are not. And here are the 4. So we have reasoning. For example, when we look at a task or something that we want to do, we can say, okay, then I should do A, B, C, and then D, E, F, and then if something happens, then I will do G, H, I. And while we are working on our reasoning or our plan that we came with, we can reflect on what is happening right now. So we took a plan, we made some steps, and then we can evaluate. This happened, but this didn't happen as the way I wanted to. I can change my plan. I can do something else. I can try to adapt. And this reflection helps us come up with better ways to achieve our goals. other than that, we also learn to use tools. Because if I would ask you, for example, what is the age of Leonardo DiCaprio, I assume most of you don't really know it off the shelf, but you can just open your phone, Google it, and you will find the answer very quickly. So we learned that we don't need to actually, for example, hold all of the knowledge in the world in our head. It's only enough if we know how to use the tool of search, that we can have access to everything that we need. And finally, we learn to work together. So maybe one human is not enough for a job, but if we use 2, 3, 4, 100, each one of them specializing on a different area, then we can reach the goal that we desire. So these 4 tools or these 4 principles are standing at the base of the concept of AI agents. So we want our LLMs to be able to give us better results, to be able to give us smarter results, and we want to help them deal with the problems we've seen using these 4 concepts. Now, there are many definitions for AI agents online. You will find many different ways that people represent them. I really like this one. I think it's very short and very to the point with AI agents. It also helps us understand that AI agents are more of a concept than an actual tool or product or something specific. And I will also give more examples for why is this a concept. So I like this definition. An AI agent is an LLM set to run iteratively with some tools, skills, and goals or tasks defined. So basically, we take the model, we let it call itself multiple times, we give it the tools, we give it the skills, and we let it know what does it need to achieve. This is the most core definition of an AI agent. Of course, on top of that, you will find many different products and many different variations. Now, the concept of an agent is probably not new to you. If you've used a travel agent, for example, which is a human agent, not an AI agent, the concept is pretty much the same. You go to the agent, you tell them, hey, I want to plan a trip for my family. I have 2 kids. We want to go to France, for example. Our budget is X dollars. Please help us plan a trip of 5 days between these dates with these and these limitations. Then the human agent will go, use their tools, search the web, find flights, try to understand which flights match your limitations or not, try to find hotels, and eventually come up to you with the final proposition for a nice vacation. So we are very familiar with using agents, delegating tasks to agents, but now we want to do this with AI. Now, maybe some of you or the more experienced among you in the crowd already know that AI agents are not a new concept. It didn't only show up with LLMs. In fact, AI agents have been around since 2016 or maybe a bit earlier with reinforcement learning. So if you haven't heard about it, reinforcement learning is a branch of machine learning that deals mostly with learning from experience, or it's really useful for games, for example. And there was a very famous publication by OpenAI where they developed this game. I don't know if you've seen it before, where these tiny characters are AI agents in the world of reinforcement learning. And their goal, the blue agent's goal, is to avoid the red agents. And they learn, slowly they learn to move around the walls, block the hole in the wall with some cubes, etc. And they publish this very nice demo where you see these 2 blue agents collaborating together, working to block the entrances to this tiny room. And you will see how one agent moves a box, then goes ahead to move with another box so that the first agent can go and complete the job. So this was very impressive at the time. And because it was so impressive, researchers thought, hey, if we taught these AI agents in reinforcement learning to work together, to move boxes, to defend themselves, what if we give them keyboards and tell them, okay, now learn to use the keyboard? So you need to do everything the same way, but just learn to use the keyboard to Google search, to write code, to do whatever. Sadly, this experiment did not really work out well, and we didn't continue down this path. At the same time, experiments with large language models worked really well. And so this is now the leading approach for AI agents. So remember, this is a very schematic concept. So what does it look like under the hood? If we are looking at an agent in today's world, in the world of LLMs, there are 3 main components that make up an AI agent. First, and most obvious, we have the tools. Our AI agent, this LLM-powered entity, can access a different set of tools that will help it solve problems. So it can access a calendar, which the developers of you probably know that implementing calendar logic is very, very, very difficult. So having a tool like this ready for you is incredible. This agent can access a calculator, a code interpreter, it can search online, it can do whatever we want, as long as it can integrate with this tool and get a response back. This is something that we provide our agent to give us value. Now there's all the buzz around MCPs. If you are unfamiliar, I recommend going a bit deeper and looking it up. It's really exciting. The second part of our agent is memory. So we need to give our agent a way to remember stuff, just like we do when we solve a problem. So in this chart, there are two types of memory. We have short-term and long-term, which I'm sure you understand why we need both to solve a very complex task. But actually, there are two more types of memories that we want our agents to have. If we think about an agent that's really serving people, that's really serving users, there are two more types of memory. We have procedural memory. For example, we want our agent that every time we contact our agent and we say, hey, please water the plants, that it will do it in the same procedural way. We don't want it to reinvent the wheel every time. So we want to have procedural memory as baked into our agent. We also want to have personal memory baked into our agent, because maybe I don't like when you cook dinner and you put the peas next to the potatoes, but another user really likes this, and we want the agent to know regarding each user what is their preference. Now, short-term memory is a problem that I'm feeling pretty confident to say that is solved with today's large context windows. You can pass Claude 200,000 tokens as input. That's pretty much all the text that you would like to pass. A lot of information can be passed over there. And then long-term memory is, I wouldn't say it's completely solved, but we have nice techniques to allow our agents to remember things on the long term, like RAG or more advanced concepts. Finally, we have the most interesting part, or at least this is what I would claim is the most interesting part, because I don't feel like it's still solved. We have the planning part of the agent, or the reasoning tool that us humans use. When the agent is faced with a task, it needs to come up with a plan of how to solve it, how to go on about it, etc. And we came up with different algorithms, methods, different types of heuristics to allow our agent to solve problems better. So you have listed a few I listed a few on the side, but this planning is pretty difficult because we also need to follow up. We need to understand how to break a specific task into different sub-goals, etc. It's also a problem that's difficult for humans, right? It's not like something that we already cracked and we know exactly for each task in the world how to break it down, how to access it in the most right way. I would say that the best problem solvers in the world today are the ones who know to decompose a very big task into smaller ones. So it's a pretty challenging task, and some of us are better at it, some of us are not as good in it. And we want our agents to be the best at this thing. So this is still something that we are figuring out in the AI community. How does this work practically? So let's imagine that I'm contacting a large language model and I say, hey, write code for a task. And the large language model says, okay, here's the code for the task you wanted. Now, I want to kind of imitate a procedural loop with this LLM. So I say, hey, here's a code for task. Please check it for correctness and give me some feedback on how to improve it. And I pass it the same code that it wrote. Now the LLM can say, okay, I spot a bug on line 5. Please fix it by blah, blah, blah. And I can take this feedback and immediately pass it back to the LLM. Right? So now the LLM can fix the bug and return version 2 to me. Now, if you're looking at this conversation, you're probably telling yourself, wait a minute, this is pretty ridiculous. Why don't we do the whole loop where the LLM talks with another LLM? We just define another one that's doing the same job as I'm doing until we get to task version 2. So this is exactly the concept of agents, right? I tell the LLM write code for a task. The LLM now has a goal, and it also has the possibility to observe the results that it's producing, to think, and to make an action. So the LLM says, okay, here's a task. Another LLM, maybe the same model, right, says there's a bug on line 5, fix it by. Then, and the first LLM says, okay, here's the second version. Then we go to the second LLM, which might have the tool to run some tests, and it will say, it failed a test. Try doing ABC. And finally, the first LLM returns the answer to me. So I get the do task final one, this time with the file. So this loop is the agentic loop, right? This is what we want to happen behind the scenes. Eventually, me as a user, I want to just say, write code for tasks. That's all I'm interested in. I want the LLM to go and talk with itself, talk with other LLMs, do whatever it takes. Use your tools, use your knowledge, use your planning, do whatever. Just come back to me with the final code for my task. That's all I'm interested in. So the world of agents is about improving this loop on the right. Now, this loop form is just one form of agent, right? So we've seen now that, okay, our agents can make observations, they make a thought about this observation, and then they take an action to fix the code, to change, to run the test, to run another test, or to return an answer. But there's a very big problem with this loop form. In fact, it's a massive problem with this loop form, which is who decides when this loop ends? Who decides how long to continue? Maybe it will never end. There are no inherent exit conditions in this loop, right? So it's possible, it's actually very possible that we would give a task to an AI agent. The AI agent will start working on this task, and it will just get stuck in this loop of observation, thought, action, and it will never finish. Or another scenario, we will give the agent a task, it will do one thing, and then it will say, okay, I'm done. Even though we know as humans that there's more to do, right? So this control logic of just letting the agent select what's the next step is pretty difficult. So what did people do? They said, okay, if we can't let the agent decide everything on its own, why don't we decide some things for the agent? So there's another simple form of an AI agent, which is not this loop, in which we, as humans, we tell the agent what it needs to do. So for example, let's say I tell you, hey, please write an essay about the economy in the Middle Ages. So I can leave you with this, and if you just try to just open up a Word document and just slam the keyboard and get the text out, it will probably be okay. Well, in case you know some stuff about the economy in the Middle Ages, you can do some stuff, learn some stuff about it on the internet. But it might help you if I will tell you, hey, before you go into this, plan an outline. Open Wikipedia, read a bit about it, plan an outline, then decide which web searches you need to do about the topic, gather some information, write a first draft, go over this draft, spot some unjustified arguments, etc., revise it, and so on, and then finally bring the result to me. So when you have this simple plan, when you have this guide for you to work with, then it's much easier for you to actually make better results. And of course, if it's much easier for you, then it's much easier for an LLM. And we are very content with this, but on the other hand, it doesn't really serve us in complex situations. For example, when we are dealing with coding practices or coding challenges, we can't just outline the way to solve it for every different coding challenge. This wouldn't work. We need to allow some freedom for the agent to decide what to do next, right? And this is where the world of AI agents is pretty much, this is what AI agents are dealing with today, right? The spectrum of control logic. Where do we place our agent or our product or the agent that we are building on the spectrum between fully programmatic or agentic? How does the agent decide on what to do next? Is it something that we define for them, or do they have full access to allow themselves to define when to start, when to stop, etc.? Now, there's a very nice analogy here that I've seen, that programmatic control logic is more like thinking fast, based on the book Thinking Fast and Slow by Daniel Kahneman. Very interesting read. Thinking fast is in the manner of you don't really need to apply logic and really go into reason and start to explain yourself what is the next step, etc. You have a list of steps and you can just go through them one after the other, bam, 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 and finish the task. On the other hand, even though it's sometimes considered faster practically, the slow thinking is the agentic flow, where every time you have the result, you need to analyze the result, decide what to do next. And we find that many companies these days, they are looking at this control logic spectrum and they are trying to figure out, okay, for my problem, whether it's AI for coding or AI for lawyers or AI for teachers, where do I place my agent? So for example, you would find articles from companies, for example, in the area of coding, and they say, okay, when we approach coding, we have this pre-processing phase that is programmatic, right? Every input will go through these same 6 blocks. And after these 6 blocks, we will switch to the agentic loop form, which is also a bit limited. You see here that there are only a few actions that the agents can take. But we found that this mix between programmatic and agentic really works well for us. So the community is still trying to figure out how do we guide agents to solve specific problems or to be excellent in different types of trade or different types of challenges. And I can't say that we cracked it yet, but some companies are saying that with enough tools, with enough knowledge, if the base models are smart enough, eventually we will get to the point where the AI can only be in the right area, where it can only be in the loop form. And I think that this is also what we want to imagine for ourselves, right? When we are thinking about this futuristic AI, when we are thinking about this AI agent that can do anything, this Jarvis, nobody is thinking, Jarvis is programmed, with an if-else that he knows what to do and it cannot change, etc. Everybody is thinking, okay, if we have this actually intelligent entity, surely it can make decisions on its own. We don't really need to tell it what to do. It will have full control over the control logic and it will execute everything over there. So this is what we are trying to, this is what we imagine, this is what we are trying to get to. Now, does it work? Is it really worth the effort to talk all of this time about AI agents if it doesn't really, show me the results? How come that we are talking about it so much, but still nobody has an agent for their Gmail or for their calendar? Is it really worth the money? So the answer is yes, it really works. And I'm showing you this image from 1 year ago, comparing GPT 3.5 and GPT-4 on a dataset called Human Eval. Now, Human Eval is a dataset of programming questions, simple programming questions, and the model needs to output a simple answer. So we can see here that if we give these questions to these models, when they just have one shot, we just give them the question and they need to output the answer. GPT 3.5 solved less than 50% and GPT-4 solved around 2/3. But once you start adding this agentic spice, right, some different techniques from the world of agents like planning, multi-agent, tool use, reflection, etc., you see that we immediately jump to the right side of the scale, and even GPT 3.5 can almost get 100% on the same dataset. And this is amazing news because it means that for less money, because these smaller models, they cost us less, we can get higher intelligence, we can get better results. It means that our models that we are working with now, maybe we wouldn't need to just increase the size and increase the size and increase the size. Maybe there is something else that we can do to get better results. And the agentic tools, the agentic concepts really work well for these types of problems. So just from a few months ago, Claude announced that their model is now 92% on zero shot on the same database. And I think that now with Claude 3.7, we're getting closer to 100. And these basic units are improving. So just think, if they are this good with zero shot, how good can they be if we add the agentic spice, the agentic concepts to these models? So this is pretty amazing, and it really makes us think, this is worth our time and effort. If we will improve the base models enough, and we will know how to apply these agentic concepts, we will get to amazing results on coding, on anything that has to do with text, or it's going to be pretty amazing for us as users. So there's a lot of promise over there, and we see that maybe you're asking yourself, okay, Jonathan, but this is just, dummy questions. Just show me the money. I want to see how it works on real data sets. So this is actually an old picture of a leaderboard on a dataset called SWE-bench from real world, real databases, real code bases, like big ones. And we saw how agents can solve it. Back then it was 22% of real world problems. Now it's more than half, and I think we are pushing 80%. So the concept of an agent can actually deal with complex problems that you are dealing with in your company today. And that's very, very, very exciting. Now, this dataset, of course, is not the only dataset that agents are being evaluated on, right? Because it's not only to evaluate them about evaluating them on code or something like this. We also want to evaluate agents for real-world domains, right? Because we understand that once this AI gets really, really smart, or we understand how to use these agents, we wouldn't only want them in our IDE, right? We would also want an agent for our calendar, an agent to help us with our home, with our lives. And it's really important to measure this as well. So we have data sets for this. We have data sets for benchmarking, how agents interact with a real computer environment. So maybe you've seen Claude Computer a while ago. It's really interesting to see how these systems interact with concepts that we are very used to as humans. So the more we measure this, the better we become at this, the faster we are heading towards a world where AI agents can actually serve us, can become very, very meaningful to us, not only as developers, but also as humans. So that's pretty exciting. Now, yes, I said that it's working, but maybe I was a bit too early to say this. Look at this tweet from Adam Silverman, who says, I used this agent to book meetings for me, and this was the result. Now, you look at this, you look at this calendar and you say, yeah, the agent succeeded, but at what cost? This doesn't seem like the ideal calendar. I don't know if anybody really wants to look like this. So here it's obvious that there's a simpler solution, right? We know that we can tell the agent, okay, so just space out the meetings and don't put everything in, with back-to-back. But what I want to show here is that even though these agents are capable of performing various tasks, we are still not at the point where agents understand the world and how we interact in the world similarly to us. So there's some way to go before agents will replace everybody or any futuristic doom sentence like this. We still need to understand how to pass some more delicate knowledge into these agents and how they operate. And yet, even though we don't have products that are super trustworthy in this domain or in any other domain, there is a lot of hype around AI agents now. Like you've probably heard a lot about it before you came to this talk. And I think there are two reasons for it. First, as the image on the left shows, I think it's the first time that we are approaching a type of artificial intelligence that feels like an AGI, like an artificial general intelligence. For the first time, after ChatGPT showed us the generalist capabilities, suddenly we are talking with a system that feels like it's actually thinking, like it's actually intelligent, right? When we give it a task, it knows, I should use a tool. I should look on the web. I should do this. I should analyze that. For the first time, it feels like you're talking to an entity that applies logic to what it does. And it's not just a model spitting out letters. And this holds a very strong promise to us as humans, as users of other products, as engineers. And we would like, the promise that it holds really pushes us forward to explore this world. The second reason that there's a hype around this is that with the advancements in LLMs, it feels like the problem of AI agents suddenly becomes very similar to the problem of the autonomous vehicles. And what do I mean by that? We've all heard about the autonomous vehicle, right? The concept is amazing. Everybody understands what we should look for. There will be this car where, because there's no driver, all the passengers can look at each other, just like the image here on the right. We don't need to look forward, all of us, because we can just get in the box and the box will drive us to wherever we want, right? It's so easy to imagine the solution, but it's very, very difficult to reach this point, right? How many autonomous vehicles are roaming today's streets? Not a lot, probably mostly in California, right? So why, even though we could have imagined this concept 20 years ago, why are we not there yet? Well, it turns out that this is the type of problem that it's very easy to imagine the solution, but it's very difficult to implement, right? And the same applies to AI agents today. So once we've unlocked the power of LLM, suddenly it's very easy to imagine the solution, but it's very difficult to get there. Now, with the advancements that we are making in LLMs today, I do predict that in a year or two, we will make significant progress towards this vision, but still, there are some subtleties, there are some concepts that are very difficult to grasp, and maybe we will only tackle them a year down the line. So we understand how close we are, we understand that we are on track, but we also understand that there's some way to go. Okay, so another nice observation about the world of agents, which I think should also increase our hope in this field is that in the world of agents, individuals are at the front. So, OpenAI just released the Agent SDK, and Claude has released, Anthropic has released Claude Code, and they released Claude Computer a while ago. But there are also many other companies, very smaller ones, for example, the company that I'm building, where the concepts of agents is being developed, and this is okay because the big companies are working on the base models, on the large language models, while other people, and people like me and you and people all over the internet, can focus on cracking the agentic concept, understanding how to control the control logic, understanding how to provide value using the agentic concepts, right? And this allows for much faster advancements in this field, right? Because not everybody can work on an autonomous vehicle in their garage, but many of us can work on using LLMs the right way to build an AI agent. So today, we are even at a scenario where many companies understand, okay, maybe it's not enough to just implement a cool chat support in my website. Maybe I can actually use an AI agent in my product to help my users use my current solution better. And it's becoming easier and easier to integrate AI agents into products, into real-life scenarios, because the research is being done so much faster by individuals all over the world. So what can we expect with AI agents in the next future? So usually when we talk about AI agents, there's always this one person who will say, this is what we need to expect. The times of WALL-E, right, where humans are just dummies sitting around and the technology is doing all the work. I think we are not heading there for now. It's not something that we should expect in the near future. But there are some changes that we need to be aware of if we think about the upcoming year or two, for example. One of them is speed. So we are very used today that when we are working with a technological solution, it has to be fast, right? If we are sending a query to Google and it doesn't come back in less than 2 seconds, we think something is wrong with the internet, or maybe something is wrong with the connectivity. Something is definitely wrong. It's taking more than 2 seconds, come on. But now with AI agents, I'm going to give a query or a task to an agent. This agent is going to go use tools, search online, activate another agent, contact this, contact that, do this, do that, and then finally give me the results. So this process can take much more time, right? Now we are not guaranteed that the technology will be faster, but rather it will give us more accurate results after it's done more for us. So we should expect that digital products, digital services would become slower, but actually it's because the AI or the agent behind the scenes is working for us and is doing many different things behind the scenes that we don't have to do on our own. So that's a change of mindset that we need to adopt when working with AI agent-based solutions. Second is that we will have to work with many different interfaces, many different ways to interact with agents. So today, some agents are activated by command line, some of them are activated by a nice UI, but we still didn't crack the way to work with the concept of AI agent. So I assume we will see many different products with AI agents that show us the way, or try to give a different vision of how to work with these AI agents. Now, something interesting to note about this is that we will probably also see many advancements in AI agents that take their inspiration from humans, right? So, for example, when neural networks were developed, we took inspiration from the brain, even though it's not exactly how it works, but we took inspiration from how the brain works. So now when we are thinking about AI agents, we want to take inspiration from how we operate as humans, how we perceive things, how we make decisions, etc. This will probably help us improve the world of agents. And something a bit more technical about this is that let's jump, like 5 years into the future and imagine that AI agents are everywhere and they help us with our code, and we can release features in 5 minutes and everything is a happy party. What happens to my CI/CD if it's just being blasted with features that are being released and it doesn't stand with the current load, right? Who maintains this? How do we maintain continuity in a world where features are just being released on and on and on, and we have developers for free, basically, using these AI agents? Now, of course, CI/CD is just a problem in the world of development, but many other fields would be impacted by suddenly a huge amount of workforce opening up for them. There are also those who predict that, everything will change. We will have LLMs as an operating system, we'll have agents as apps. There's going to be a big shift. I think it's really important to focus on the more right here and now aspects of agents. And the biggest change is that, for example, developers would be much more free to deal with the actual problem at hand. As humans, we would think about something that we want to do, we would think about the problem, and we will delegate all the work, all the things that need to be done to an agent. But we would still be free to think about the core business problem, the core technical problem at hand. We wouldn't have to get to the nitty-gritty and actually run some lines of code, etc. So now it's kind of the golden age for agents. We are standing at the beginning of the golden age for agents. We already see products, for example, for coding like Cloud Code, OpenHands, Devin, Fine, Manus that are saying that they are developing a general AI agent, Grok. We are seeing many different products today that try to help you in bringing this agentic flow into your daily life. So even though maybe you're going to leave this talk and you're saying, okay, this is nice, but how do I work with this? How do I find it in my day-to-day life? I say go to these products, go to these flows, try to play with it right now, because in a year or two, it will be your main tool. We will leave our tools that don't have an AI agent for tools that are much more useful for us. So the tools are already here. We need to look for them. We need to start working with them. The best way to prepare for what's coming in a year or two is to start working with these solutions right now. You will understand the limitations. You will understand how to better shift your work to match that work, to match the style of the AI agents. So go ahead and give it a shot. I guarantee that it's going to be a very fun adventure for you to go out and try these tools. It's super fun and super interesting. People are building amazing things out there today, and it's really worth your time and effort to look into it. And it's also pretty easy, right? Because we are building products that are meant to serve us. So that's pretty great. One final thing that I want to mention about AI agents and how they shift things in our real world, in the business, for example, there's this new concept called vibe coding, right? Where a person can say, okay, the AI can code everything for me. I just need to understand the vibe and guide it with my language, and it will take everything from there. And you might think to yourself, well, this is a nice concept, but does it really work? Is it really happening today? Then maybe you've seen this simple game developed by a guy called Levels.io on X. Amazing. This has been amazing 3 weeks of his life, I assume. He developed this in under a few days, and in less than a month, this product somehow got to somewhere close to 80,000 in revenue, in a monthly recurring revenue. So now entrepreneurs, people with business, if you just learn and get into the mindset of working with agents, you can already improve your day-to-day work by at least 10%, if not hundreds of percent. So I would love to stay in touch with you if you enjoyed this talk. If you are curious more about AI agents, please leave your details. I would love to continue the conversation here on LinkedIn, on Twitter, wherever you are. If you have a tool that you use and you are curious about, please feel free to reach out. I'd love to stay in touch. And thank you very much. Thank you for having me here in Azure Day. It's been a pleasure.
We can't hear you, Costas.
I'm sorry I was speaking, but I was on mute again. Thank you so much, Jonathan, for being here with us. Your content was amazing, and we had the opportunity to see a cutting-edge technology, a cutting-edge framework, something that we're going to see more and more in the coming future. We will stay connected, Jonathan. Hopefully, we'll see you in another event of ours. I don't know if we have any questions. Let me have a quick look. No, everything was all right. So grateful, Jonathan, for being with us. Have a great one, my friend. Bye-bye.
Thank you.
Well, we're waiting for Harun to come join us with Arun, I'm sorry, build your first AI application with RAG.
Yeah.
I don't know if he's here. Naveen, have you seen him? No?
No, I think we can make it for 10 more minutes. I think
We
scheduled
can
after
wait.
5 p.m.
Okay, I
So we
will
can.
play our video and our moderator will be kind enough to add Harun when he comes. Thank you everyone for being here. Let me play our video and we will be right back with you.
Hi, Arun.
Hi Costas, hi Naveen.
Hello,
Hi, Arun.
hello.
Welcome everyone to the Azure AI Connect. This week, from March 10th to 14th, we are exploring how to shape the future of AI. Today, our topic is on building RAG applications by Arun. Welcome, Arun. The
Yeah,
stage is
thanks Naveen.
yours. Um,
Yeah, thank you.
if you can share your screen, I can add that to the stage as well.
Yeah, sure. Can you able to see my screen?
I'm adding it now. Yeah, the stage is yours. Please go ahead.
Yeah,
Thanks for being here.
yeah. Thanks Naveen. Hi everyone. Good morning, good afternoon, good evening from wherever you have joined. And thanks Costas and Naveen for this wonderful event. And thanks Azure Developer Community Tamil Nadu for organizing this wonderful event. So today the topic is all about how you can build your own AI-powered applications with RAG and OpenAI. So that is the topic it's going to be. It's going to be a fun, like demo-oriented session. Okay. So first of all, about myself, I'm Harun Rashid Bashir. I'm a Microsoft MVP in data platform. I work as a data engineer specialist with Hitachi Solutions. So I work around data and AI stuff. So let's start with the session. So I'm going to start the session with this wonderful term called every app will be reinvented with AI. So we all know, right? So whatever the applications that we were using, conventional applications. So for every app nowadays, we are introducing the AI flavor into it because all our clients need that AI or our end users needs AI in our application, in our existing application, right? So that is how this AI era is running. Okay. So with that, we just want to understand like how this Gen AI is evolving. So to reach 100 million users for mobile phones, it took 16 years exactly to reach 100 million user, and for internet it took 7 years. For Facebook, it took 4.5 years. But for this Chat GPT, it just took 3 months to reach 100 million users. Okay, that is a massive growth, right? Because each and every one of us is using a Chat GPT on our day-to-day life, either for our official work or our personal work, right? So that is how we are overwhelming with Chat GPT. So what we are going to do is today I'm going to explain you about what is Chat GPT or what is model, right? Basically, for every AI application that you are using, behind that AI application there is a model sitting, and it is helping you to get the answer or the response for your prompt. That is what we are going to see today. And with that knowledge, we are going to build our own AI powered applications, and also we are going to build a RAG based application. That is all about today's session agenda. Okay. So without further ado, I'm jumping into this Microsoft AI journey. So this is just a roadmap of Microsoft from where they started and now where they are in. Okay. And this is all about the Azure AI services we have. Okay. So currently we call this Azure thing as a Azure AI Foundry, where you have all the models, your agents, everything is in one place. In some time, we are going to explore this AI Foundry as well, because here only we are going to deploy our model and use it for our application. Okay. So before doing this Azure AI Foundry thing and create our own application, we need to know how actual things are working, because as an end user, if you are going to create any model or fine tune any model, you need to understand how the foundation model is working, right? How the base model is performing, what is happening in the back end of the model, all those things we need to understand. So for that, we are going to understand like how our language model works. Okay. So basically, for our Chat GPT, as you all know, the model used is a GPT model, right? For your Meta AI, the model used is a Llama model. So like that, for every AI application, as I already said, there is an model sitting behind that, right? So we are going to understand how these language models actually work. So yeah. So we need to understand what is the difference between AI and ML models. So few years back, right, a couple of years back, everyone was like, I'm going to create this ML model for my prediction, all those things. They'll be saying only ML models, but now everyone is saying about AI models. So we need to understand the difference between these two things first. So ML is nothing but it's a subset of AI. Okay, so AI is not a new thing. Like when we started coding, when we written like if else condition, right, that itself is an AI. So on behalf of you, if some code is doing some work, that is an AI, right? So that is the difference between this AI and ML. So AI is nothing but it mimics like a human. Okay, it mimics like a human intelligence. That is AI. Okay. So with that, we are going to understand how this, what is LLM first of all, and what is SLM, so that we will understand what kind of thing we can use for our application. Whether I should go for an LLM or I should go for an SLM. Okay, we should understand that thing first. So if you see here, LLM is nothing but a large language model. SLM is a small language model. So all your GPT, Gemini, Claude, everything comes under large language model because those models or got trained with trillions of parameters. That means, let's say all your open source data, they accumulated and they trained the model. But for your some cases, right, for example, the models that you're running in your edge devices like your mobile phones or your laptops, so those models, right, for similar applications like your Apple Siri, okay, it doesn't need trillions of parameters to get trained, because it is going to do some set of jobs, okay, which doesn't need a trillions of parameters. In those cases, you can simply go with the small language model, that is SLM. That is the major difference between this LLM and SLM. Some commonly used SLM models are Mistral, Phi2, and Tiny Llama. These are the commonly used SLM models. Okay, and here I have given like some of the use cases and where I can use my SLMs. You can see I can use my SLMs in my Android or iOS edge devices, right? My simple keyboard AI can use a SLM. Okay, but for LLM, the use case is different, totally different. Any chat GPT applications or any chat based application, if I want to use a model, then I need to go with the LLM model. Okay, so these are the basic difference between this LLM and SLM. So basically you compare this SLM with a monk who is climbing a mountain. So whenever a monk is climbing a mountain, he will not carry a huge stuff, because if you carry huge stuff, you cannot climb the mountain swiftly, right? So if you want to climb the mountain without any hurdles, he should not carry anything, any weights. So that is SLM for us. Okay, yeah. So with that LLM and SLM, now we are going to understand how this actual language model works. So we all know, let's take ChatGPT as an example. So we all are giving a prompt. The question that you're writing to the ChatGPT is called as a prompt, right? So whenever you are giving a prompt, it is giving you an response. But all we need to know is how exactly the response is coming, because whatever question I'm asking, it is giving me an answer. If you like go back a couple of years back, there are like some chat based applications are there where it is purely on question and answer based. We call it as a knowledge based or Q&A based chatbot. That means for a set of questions, it will be giving you an answer. If you ask any questions out of the context or out of its knowledge, it will say that I don't equip with this knowledge, you please contact the customer care. Like that, it will be giving some prompts, right? Because they all are like equipped with some questions and some answers. But nowadays all our AI applications or AI based chatbots, it is not a Q&A based model. It's like it is having the global knowledge, right? Means all your open source data, we took and we trained that model. Okay, so we need to understand how exactly that is happening. So as we know, machines or models doesn't understand alphabets. That means it doesn't understand any language, English language. So obviously whenever we are training the model, we are going to train the model with numbers. Whatever the content that you are training, right, the data, that will get converted into numbers, vectors, and it will get saved into the model. So whenever you are giving some prompt to the model, what will happen is that prompt vectors will go to the existing vectors in the model, and based on the probability distribution, it will push the answers out. Basically it will push the tokens out. So those tokens only we are seeing it as a response. So that is the idea, and that is the architecture behind this language model. Okay, and also we need to understand whatever the prompt that we are asking, the answer won't be like in a full stretch, it won't be come as an answer or as a response. So whenever you are sending tokens, always you should remember this principle. The principle is n tokens in and 1 tokens out. That means how many tokens you are going to send. Basically the tokens are like, if you want to understand the tokens, this is a token. For example, if you are sending this as a prompt, it will get converted into 11 tokens. So these 11 tokens will go inside the model, and when it comes out, right, it will not come as like the entire answer. It will come with only one prompt as an out. Okay, you can see only one prompt will come out. How that will come is, let me show you that. So this is how the response will come. Each and every response will come as a one tokens out. Okay, so these tokens will again combine with the existing tokens, and it will go inside the model, and it will predict the next most likely token. So this will be keep on going in a loop, and it will complete our entire response. So this will give you a clear idea. So you can see we need to is the input prompt, and the out token comes will be the stop. Okay, so once that out token came, that is stop token came out, it will again go inside the model, and the next likely token is anthrof. Okay, so like that in a loop it will be keep on going until we get the proper response. The last response is we need to stop anthropomorphizing chat gpt. So this is how any model, or at least our GPT model, which follows the transformer architecture, will be giving out the prompts, sorry, the response. Okay, so with this, you can see here there are two parameters basically decides this uh, out tokens. One is temperature and top p. Okay, so based on this temperature and top p parameter, we can able to widen the creativity of this model. Okay, so if you increase the top p and the temperature from 0.1 to 2, any range, right, if you increase from 0.1 to 0.5 or 0.6, the creativity of the model will be enriched, because you are widening the token selection basically. But when you reduce the top p and the temperature value to zero point 0.1, you are narrowing the token selections. Okay, so those two parameters we should understand. Don't worry, I'm going to show you those two parameters when we are creating our actual application. That time you will get a clear idea what exactly those two are. Okay, so this is how the any model work. So as we already discussed, right, so any model you take which follows this transform architecture is going to predict only the next most likely token. It is not going to predict the entire response at a single stretch. It only predict the next most likely token. Okay, so that is what we need to understand. So how you can interact with LLMs? See, as a human, we are interacting with the language, right? Like that, how you can interact with LLMs. So there comes this concept called prompt engineering. Okay, who is a prompt engineer? So each and every one of us should be a prompt engineer, because we are interacting with LLMs. We are interacting with chat GPT, right? So when you are interacting with any model, you should give a contextual prompt. Okay, if you are giving some vague prompt, the model also will give you some vague answer only. So you should be very conscious about what you are giving as a prompt to the model. Okay, so whenever you are giving a exact prompt with concise context, it will give you a proper response. Okay, so let's say what is the largest ocean in the world? If you ask this, right, it will be giving you this kind of an vague answer. But if you are expecting some kind of a numerical, or if you are expecting some kind of an research oriented answer, then you should be setting up the context. Okay, you should be setting up the context to the model. Then if you ask the question, it will be giving you the answer in that particular manner. Okay, so these kind of things we need to understand. Let's talk about this context setting, all those things in our upcoming slides. Okay, so let me take you there. Okay, so the context one that I said, right, that you can also call it as a system message. Okay, so for example, you can set it like, if you simply ask what is a name to any model, it doesn't have any name. Okay, it will simply say that I don't have any name, but you can call me an assistant. But what I can do is I can set up a system message. The system message is simply like, I can go to ChatGPT and I can say that consider yourself as a friendly assistant called Hank, and you always respond in a rhyme. If I say like that, then from that point my model will respond like this. Whenever I ask what is your name, my model will respond like this, like my name is Hank, and it will speak in a rhyme, because I already set the context like you should always respond in a rhyme. Okay, so this is how you set up the context using system message. Okay, I hope now you got some idea about this prompt engineering. Okay, so if I ask a fun fact about a raccoon, it will give some rhyming response. Okay, but if you are not setting up the context as a fun, friendly system message, right, it won't give you in a rhyme manner. Okay, so that we need to understand. So these are some of the recommended system message frameworks. Maybe I will be sharing this slide with you. That time you can go through what are all the message frameworks available. Based on that, you can use. Okay. So these are the model parameters that I already discussed, like temperature and the top P parameters. Again, we are going to see this while doing our demo. Okay, with that, coming to the main part, the retrieval augmented generation, the RAG. So whenever you are asking some question, that is our prompt to a model, right, it is going to give you an answer. But if you want to prepare an application or create an AI based application for your organization, and that response should be a organization specific response, then what you need to do is you need to go with this RAG approach. Why? Because if I ask, for example, if I'm running a technology based company and I want to create a some kind of uh, tech tech support application, tech support chat application. Okay, if my end user is going and asking how to set up my internet connection, the model will give you a vague answer, like it will give some all list of possibilities internet setup, right? But I am running a ABC internet company, it won't give an answer specific to ABC internet company. So that time what I need to do is I might be having, as a ABC internet company, I have the steps to set up the internet connection. So I will be converting the data as a vector and I will save it somewhere. And whenever someone is asking a question like how to set up an internet connection, it needs to get the information from my data. Along with my data and the end user prompt, those two information will go to the model, and now the model will give you the exact answer or the exact response on how to set up the internet for ABC internet company. Okay, so that is how the flow works. Here you can see user question, that is a user prompt. Query my data. Query my data is nothing but whenever the user is giving the prompt, right, that prompt will go and check the result from my data instead of directly checking it from the model. So from my data it will get some answer, and that answer will add it to my prompt again. Then those two things will go inside the model and it will query. Now I will get the answer out from my LLM, and that will be displayed to the end user. So this is how any RAG works. Okay, so now I'm going to show you how this RAG works. Before that, let me create you an simple application. So for that, I'm going to Azure portal. Okay, I hope most of you are familiar with this Azure portal. If not, portal.azure.com is the link that you need to navigate to get into the Azure portal homepage. So here, as we already discussed, there is a separate service for AI called Azure AI Foundry. So I already created one. This is the Azure AI Foundry service that I already created and have it with me. If you want, you can simply go and create a hub and then give some basic information about your subscription, your resource group, in which region you want to deploy this resource, the name for this particular service, and that's it. Okay, and you should add a storage account to this particular hub. You need to give some storage account information as well. Let me create one for you. So let me attach it to my existing resource group itself, and let me deploy this in East US region. And I'm going to give this name as Global AI Greece 02. And then the storage, it automatically took some default name. I'm good with that. And other things, I'm not changing the default settings, and creating my Azure AI Hub. So AI Hub is nothing but an one-stop solution for all your AI need, right? I'll be showing you what are all the things available in AI Hub. It will take a couple of minutes to complete the setup. Basically, a request is going to Azure for creating this AI Hub now. Basically, it will get deployed in the East US region. You can see the storage account, key vault, and the other services are getting created as part of this particular AI hub. Yeah, it got completed. Let me go inside the service. I'm launching the AI Foundry hub. So this is my AI hub. So in this, I can create n number of projects. So let me create my first project here. So I'm going to give this as global AI project underscore Greece. Okay. So I'm creating my first project here. So you can create a number of projects under a single hub. So basically what I'm going to do is before RAG, I'm going to show you how you can create any model or utilize any model available from Azure AI Foundry and create your own application. Okay. So for that, I need to deploy some model. Okay. There are a lot of models available. So this is my project. Okay. Under the AI Hub, I created my first project and project name is Global AI Project Greece. Okay. And I have a lot of models available here. If I go to models and endpoints, I can able to see a lot of models here. Okay, if I see, okay, I can go to model catalog and show you everything. See, all the commonly used models are available here. You can deploy any model that you want. Okay, but what I'm going to do is now I have a use case. Okay, my use case is like I want to build an AI based application which is an helpful for HRs, human resource persons. Okay, they might be getting like hundreds of resumes. So what I am going to do is I'm going to create an AI based application which is going to do the resume parser work for them. For example, they are getting some 100 resumes for a data engineer role, and they want to rank the resumes based on the job description. Okay, so based on the highest rank, they can call the candidates for the interview. So for that, I'm going to use an AI. For that, I know the model that I need to use, embedding model, because embedding model is nothing but uh, the embedding model used to convert your data into vectors. Okay, so that is the idea behind the embedding model. So I need embedding model. So what I'm going to do is I'm going to deploy embedding model. Okay, so let's say embedding, I am interested in embedding 2. Okay, yeah, embedding ada 2 model. Okay, so let me go here and deploy this model under my project. Simply I can click on deploy. That's it. And you can see the capacity 120k tokens per minute. I should be good with that. So I deployed my model. This is my model name. And to consume this model, I have the endpoint and I have the key here. Okay. So what I did is I have created one simple application using a Python code here. Okay. So what is this application is going to do is this is going to do the resume ranking as I already mentioned. Okay, so how to use my model here? You can see Azure OpenAI endpoint and OpenAI key. What I'm going to do is I'm going to take the endpoint from here. I'm going to replace my existing endpoint. This is my existing endpoint, so I don't want to use my previous one. I'm going to use my new endpoint here. So this is my new endpoint, and the respective key is this one. Okay, I'm using the key here. Yeah, that's it. So let me go through this code for you. This is nothing but simple Python functions that I have written here for doing the resume ranking. Let me run this application and show it to you first. Yeah. So this is a localhost application. So as I already said, you can see the HR can choose any job title they want. Let's consider they are looking for a data engineers, and the skill sets they can choose from here. They can choose multiple skill set, and if they have any job description, predefined job description, they can give it here, or let me say SQL, SP, CI, CD, like that. Simply I'm giving okay, and what else? DevOps, okay. And they can choose all their resumes, like hundreds of resumes that they have. Okay, let me choose some of the resume, sample resume that I have. 3 resumes I have selected, like that. They can choose how many resumes they have. I'm just submitting this. You can see here my resumes got ranked. Okay, this resume is having 79% score. Basically, I didn't convert it into a percentage, but you can consider this a 79% score. This is 79.14. This is 77.66. Okay, basically, HR works got easy now. They no need to open each and every resume and go through the each and every resume. Or sometimes they might be missing when they are getting like hundreds of resumes. They might be missing some potential candidates. Okay, in those cases, now they will not miss any potential candidates, right, to get into the interview process. So how I achieved this, let me show you the code. You can see here I'm using this concept called cosine similarity. So what I'm doing is I'm converting all my data, basically all my this data, the job title, the skill sets, the job description, I'm converting these things into a vector, and also the 3 resumes that I uploaded, right, those 3 resumes also I'm converting into a vector. So those 2 vectors now I have, I'm calculating the cosine similarity between those two. So whenever the cosine similarity is less, the rank is more. That is how I have written this code. Okay, so that is the idea behind this cosine similarity. So that's how I achieved this. For this, the model that I used is the text embedding ada not 2 model. Okay, so this is the basic thing, or easiest way to use AI in your application. Okay, so now going back to your RAG, let me go back. Okay, so now our ultimate aim is to create an RAG based application. So what is RAG based application? First, I will show you a chat application without implementation of RAG. Okay, consider I'm having a company called HR data company. Okay, so in that HR data company, I want to build an chatbot. Okay, so let me build a chatbot using GPT-4. Okay, GPT-4, 8K tokens per minute. It should be fine. So for this particular chatbot, I'm choosing GPT-4 model, base model. So you already know, right? This GPT-4 got trained with some trillions of parameters, so I can ask any question to it. But as an employee of HR data company, if I want to ask some company specific question, for example, I want to ask about my appraisal cycle, this model cannot answer correctly, right? It cannot give an exact answer because it will give a vague answer. We are going to check that how it is going to give an answer, and also we are going to implement RAG and check how it is giving an answer. Okay, that is the difference we are going to see before and after the implementation of RAG. It is taking some time. Yeah, create resource and deploy. Let me refresh this. Yeah, I have a GPT-4. Okay, so I can this one, right, this is the system message. Few minutes back I have said, right, about setting up the context. So what I can do is I can set up the system message here. You are an AI tech assistant of HR data company. Okay, so like that I'm setting up the system message here. So, and also I can give like give polite answers to the end users. I'm just changing the system context here. So now onwards, my model will behave as an tech assistant who is working in a HR data company, and it will try to give some polite answers. Okay, so I can go and ask like, "Hi, how are you? May I know whether I will be part of this 2025 March appraisal cycle, I joined the company in the last year, June 2024. So I'm asking this kind of an prompt, but since this is just connected with the GPT-4 model, it cannot give a proper answer related to the HR data company, because HR data company is having some set of policies, right? See, it is saying that I'm doing good regarding your query. Whether you will be part of the March 2025 appraisal cycle typically depends upon the company policy. And this guy, this GPT-4, doesn't know the company policy, doesn't know which company it should work on. Only it knows that it should behave as an HR data company tech assistant. Okay, so it cannot give a solid answer. Okay, so what it is saying, to get accurate information, I would recommend checking with your HR department. Okay, but I want to build an scalable and effective AI based chatbot. Okay, in that case, what I can do is I can implement a RAG here, that is a retrieval augmented generation. So for RAG, what I can do is, so I need to have my own data with me. So let me show you what kind of a data I should be having. So this kind of data I can prepare. Okay, you can see I have prepared some sample HR data company performance review policy document. So this will be having some informations or handbook related to when the appraisal cycle, and who are all eligible for the appraisal cycle. Okay, all those informations will be available. This is a handbook. So now as a part of RAG, I can use this document and put it as a RAG document, and let's see how this is performing. Okay, so what I'm going to do is, there are a lot of ways to do this. Like you can simply upload this as a file, or you can put it in a database, or you can put it in a storage account, anything you can do. So how to do that? If you see here, there is an add your data button. You can go here and you can say add new data source. Okay, so in this data source, as I already said, you can use from MongoDB, you can use it from Azure Blob Storage, or you can simply upload it, or any URL you can put. Okay, all these options are available. As of now, I'm going to get it from Blob Storage. What I did is, I already uploaded my document, right? The same document that I showed you. I uploaded that document in a simple storage account. Let me show you that. I created one storage account and I created a container called company data. Inside that company data, I uploaded my HR data company performance review PDF document. Okay. So what I'm going to do is, I'm choosing Azure Blob Storage, and the blob name, let me choose the storage account as, what is my storage account name? Global AI 2025 HRB. So this is a storage account. The blob container is company data. Authentication method, I should go with the account key. Let me get the account key from here, from my storage account. And I'm giving connection name as HRB just for my identification. And I'm choosing the HRB that we created just now. And you can see the document available here, right? So this document, I'm going to convert it into a vector index now. Okay, so I'm selecting that and I'm converting that. So for this, we need an Azure AI search service. So I have an existing search service. Let me use the existing search service itself. This is nothing but an another Azure service. Okay, you can simply go to Azure portal homepage and you can search for search service. Okay, so Azure AI search service. Here you can create one resource. That resource is available here for me. I am using that existing search service resource. I'm using this vector index name, and when and all I want to refresh this index, like one time or hourly or daily. As of now, I'm going with the one time. Okay, so based on the data in your storage account, how often you put new data into your storage account, you can select these schedules. Okay, as of now, it's a one time data, so I'm going with the one time. That's it. Okay, I already consumed my quota, no issues. Once I click on next, what will happen is, simply my data will get added here. Okay, once my data get added here, it will take like a couple of minutes for the ingestion. Once the ingestion is done, my application will be converted as a RAG based application. Okay, so since it will take couple of minutes, I already uploaded a data and kept it for you. You can see here in my another project, I have already uploaded the data and kept it here. So now if I go and ask the same question here, I'm copying the same prompt and going here and I'm pasting the same prompt here. I'm pasting the same prompt. Now see what is happening. Let me check why this is behaving like this. Hybrid, advanced settings. Okay, the rate limit exceeded. We'll wait for another 40 seconds. By the time, let's see whether I can able to add it here. Another 3 seconds. You remember there is a limitation like 8K tokens per minute was the limitation I had. So that is the problem here. Yeah. So let's ask the same question now. Again. We'll wait for another minute. By the time we can see these parameters, we discussed about this top P and temperature parameters, right? So these are the parameters here. So you can change from 0.1 to 1 here. So based on this temperature and top P values, you are going to widen the or narrow the token selection. Basically, if I increase this right to 1, my model will be like more creative. It will give you like more creative answers. But if I reduce this to 0.1 or less result value, it will give some uh, system based, or I can say like narrow answers only specific to that particular context. Okay, so the creativity will be very less. See, now it is saying, will I fall under 2025 March appraisal cycle? I joined on June 2024. Now it is giving me a proper answer. Based on the retrieved document, the company performance review policy state that employee who joins before September qualify for the December cycle. Since you joined June 2024, you would have been eligible for December 2024 review cycle itself. Okay, so this kind of an exact answer it will be giving only when you implement a RAG, and also it is giving you the reference document from where it got the answer, right? It is giving a reference document. So this is how you create any RAG based application. These rate limit exceed and all, please ignore this, because I had that 8K limitation. I can increase that limitation at any point that I want. Since this is like a demo, I didn't increase it. I have used only with the 8K limitation. But once the RAG has been implemented, as I already said, you will be getting this kind of a specific answer from the document that you have vectored and kept. Okay, so this is how you implement any RAG. Now if you want to deploy this as a web application, or you want to accommodate this kind of a chat application in any of your existing code, click on this view code, get this code in any language that you want, available Python, JSON, C#. Okay, get this code and accommodate this in your existing code, or simply you can deploy this as a web application directly. This will get created as an Azure web application, and from there you can use this as a simple web app. Okay, so this is how you create any of your RAG application quickly and swiftly. Okay, so this is how you use your Azure AI Foundry to do that. So that's all I have to show you how to create your first AI application and also your first RAG-based AI application. If you have any queries related to this, you can put your questions in the comment section. We'll be happy to answer those things. And if you want to reach out to me through LinkedIn, you can always reach out to me in LinkedIn in this ID. I'll be happy to help you for any of your AI and data-based questions. Yeah, that's all I have for today. I hope you got some information from today's session. Yeah, thank you all. Thanks everyone. Thanks Kostas and Naveen.
Hey Harun, thank you so much for being here with us. It was one of the most deeply technical sessions we have. Uh, Again, we are grateful that you could deliver. I'm so glad that we met and we are connected now. I will hit you up on LinkedIn, absolutely. Harun, have a great one.
Yeah,
Bye.
thank you Kostas. Bye. Have a great day. Thank you
Bye
all.
bye. Yeah, that was Harun, uh, and one of the excellent sessions of our Azure AI Connect multi-session event. We have so many amazing speakers, including Harun. I'm going to add now a video until our next speaker. Thank you very much. Hello, hello. We are back. This time is the correct order. We have Wilder with us from chatbot to goal-oriented AI agent using Semantic Kernel. One of the most, let me say, exciting sessions for me since I'm following very closely Semantic Kernel, and I'm very curious and intrigued to hear our next speaker, Bill. Thank you, Bill, for joining. I'm sorry for the break mix up. I thought it was your turn, but you just going to have a pick. Anyway, now it's your turn. It's your the stage is yours. I want to thank you for being with us, and I'm so grateful that you can deliver. I'm going to be on the backstage. I'm adding your screen now, and the stage.
Great. Thank you for the kind introduction, and welcome everybody. I'm excited to be here. As you just heard, my name is Bill Wilder, and I will be going through some of the key components in building a semantic kernel application in C# that accesses a large language model. And the I will focus on the part, I will kind of transition from the, I'll bring you from the simple parts and I'll transition into some more sophisticated parts that make it agentic, which I hear is the buzzword of the year. Not much. I want to talk much about myself, but I run a community group called, used to be called Boston Azure for the first 15 years. Now it's called Boston Azure AI. And we also host events virtually. We host them in person in the Boston area in the US, and we host them virtually also. So feel free to check us out there. A brief history of artificial intelligence, and I will relate that to semantic kernel momentarily. From the 1950s, we've had the term artificial intelligence, and then I would say that there was a half a century where there wasn't a big impact on society. A lot of progress was made, and many of the underlying learnings helped power what we have today. But I think it's a reasonable statement. And in the early 2000s, we shifted from languages like the Lisp programming language that also stems from the late 50s, early 60s, expert systems. These were hand-coded rules. We would go talk to a human expert, we would extract their knowledge. But now it's shifted to a data-powered world. And this is, of course, machine learning. And this, of course, became feasible when we had the internet. We had so much data that we could power our machine learning models with Wikipedia, YouTube, everything. And then the LLM is basically a subset of the machine learning field, which is a subset of the overall AI field. And then, of course, in 2022, ChatGPT hit the streets. And then just a short time later, according to this commit message in the Semantic Kernel GitHub repo in February, so I think that's slightly less than 3 months, the Semantic Kernel project was started at Microsoft. Semantic Kernel is serving 3 languages, Java, Python, and .NET. That's an interesting strategy. For enterprise developers, the Java and .NET parts are pretty relevant. And this talk is going to focus on using C# and .NET. There's a relevant differentiator here where you might use Python to build your LLM, but probably you don't need Python to consume an already built LLM, which is the more numerous case. So I think there's a pretty significant role for C# and Java as integration technologies for LLMs into the future. Semantic Kernel, what is it? I mentioned it's a open source GitHub repo that was started shortly after ChatGPT lit up. And what it has evolved to is a SDK for interacting with LLMs, and the LLMs can vary a lot, so it can be cross-vendor. So that gives you a portability lever, and also certain functionality is pushed down into Semantic Kernel, making it more generically available. We're going to talk about tools and what I generically call tools. Semantic Kernel might call a plugin or a function, and this is either prompt, a semantic tool, or code. Arbitrary code, a native function that you can give the Semantic Kernel, through Semantic Kernel, you can give to the LLM as a tool. Semantic Kernel supports a lot of stuff. The chatbot style is pretty common, and it supports agentic behavior today. That's where we'll stop this talk. At the end, we'll get there. And then the agent and process frameworks. These are 2 separate frameworks that are also under the Semantic Kernel moniker. And the agent framework, some of that just reached release candidate 1, and the process framework is still evolving. But there's a lot of exciting energy coming out of the Semantic Kernel realm. I'm going to go through 6 concepts, and I'm going to relate them to Semantic Kernel and to general AI. So I'm going to spin through these pretty quick. I assume these aren't all new, but I want to tie them together. So the first key concept is the large language model. And in this talk, the sample that I'm going to use runs off of the Azure AI Foundry, which formerly AI Studio, which is you might think about it as a models as a service host, and has all kinds of models available, like a chat completion model, our friend GPT-4o, DALL-E, the image generation model, and we'll show a quick demo that uses the embedding model too. So we're going to focus mostly on ChatGPT-4o based chat completion, because that's an easy way to build a useful application, including agentically, and with a slight deviation there. But that's your home. Like, you can get lots of models from this marketplace, and there are other options too. You can even run models locally. That all is happily interacted with by Semantic Kernel. Just some real basics. Semantic Kernel is, you might imagine there are a few packages that you want to use. You download it as a NuGet, and here are some of the options. And the Azure OpenAI says we want to use, in this demonstration, we're going to use Azure hosted OpenAI models. This could be other vendors. It could be, that's basically how you connect to a model. And this is just, again, this is simple C# plumbing. You need a few values that you get from Azure, from the Azure AI Foundry, such as a deployment name, an endpoint, URL, and an API key. Just simple stuff, just pointing it out that there's no different here. You can get these values from the environment, like I'm showing in the sample code, but it could also come out of app settings. If you're running this in an Azure function or a Kubernetes or anything, those have their own mechanisms for storing values. You can always use Azure Key Vault, etc. Standard stuff. And quickly, then once you have the basics, you can instantiate a kernel, and the kernel is the thing that allows you to make calls into your LLM, and other routine stuff is available. Just to mention, dependency injection is a first-class citizen. Semantic Kernel plays very nicely with that, and other standard C# features like logging and OpenTelemetry and beyond. Okay, so just basics there. With what we just talked about, we gave Semantic Kernel access to our LLM running in Azure AI Foundry. So let's go on to tokens. The way that tokens work in the LLM realm is they serve two important functions. One is as a prediction unit, and the other as a billing unit. The large language models and small language models, they produce tokens, and you can think about an LLM as basically a next token predictor. We'll talk just a little more about tokens momentarily if that's not a solid concept for you. What is a token? But it's a prediction unit. So give it a prompt or a whole chat prompt, and say, what's next? What's the next token? Give me a token. And it's also a billing unit. You pay for tokens. You send it a prompt, it's a certain number of tokens, and you get back some results, a certain number of tokens. That's how you pay for this service. We'll see this repeated a few times, where you can provide some what is called here prompt execution settings. So you influence how the LLM behaves by specifying certain values. One of which you can indicate to the LLM, don't use more than a certain number of tokens. If you give a very small number, like 10 tokens, you're not going to get a useful result back. It's probably going to be some short, truncated thing that doesn't hold together. 500 might be a useful number of tokens to use to get a valid response. And it can keep going up well beyond, it's up to the particular LLM what its context window is, which is the maximum number of tokens that it can handle in one interaction. So you can control your costs and the time it spends as well, because the longer the more tokens it has, the more work it can do through this max tokens variable. So I should stop here for a moment and point out that when you use a user interface like a ChatGPT or a Copilot from Microsoft, Perplexity, etc., you don't get to control, or at least mostly, I'm not aware of you being able to control these type of parameters that I'm going to talk about today. So the programmatic control gives you much more manageability over how you want your LLM to behave and how much work you want it to do and so forth. Let's talk slightly more about tokens. You can go to platformopenai.com/tokenizer and you can run these yourself. If you type in these words, winter is coming, as opposed to capital winter is coming, this is still 3 tokens. These are each 3 tokens. If you do all caps winter is coming here, this is 5 tokens, and this one actually has a new line at the end, and you can see that the new line, or I'm telling you that the new line is actually part of this, or is actually its own token. It's the 4th token as compared to this one. So tokens, how do you know whether this is the same token as this? They actually have identifiers. These are also available in the tokenizer, and you can tell though that capital winter is a different token than lowercase winter, and all caps winter is 2 tokens, 2 different tokens, and so forth. So you can see that the tokenizer is sensitive to things like spacing and punctuation and new lines and capitalization and so forth. Some more, another example. And then as far as token count goes, what's your spend? You've given it a max token count. This is a logging statement from the agent that we'll look at. And the prompt is, in a single run-on sentence, introduce a famous programmer, period. And if you bring that to the OpenAI tokenizer, you'll see that it will claim that that has 20 tokens, that should match. And the response we got here about Linus Torvalds took 43 tokens so I used up 62 tokens to have it make that sentence for me. So just showing you how that all holds together. This is standard logging from my my application. I'm actually not going to demo this in the interest of time, but it's you don't need an account or anything to go use that. So we've looked at tokens, what it is. You can see your usage from Semantic Kernel, and you can control usage through Semantic Kernel. Let's talk briefly about embeddings. So embeddings are pretty cool. And we saw when we looked at the models as a service screenshot from Semantic, the Azure AI Foundry, that there are a bunch of different models represented. And the one that was circled in the second column, I think it was a text embedding model, text embedding 3 large, that came out about a year ago. And if you think about a so embedding models represent meaning, semantics. So if you have some text, you can ask the model to, you would turn it into tokens, and then you'd ask the model to turn it into meaning. And it does that by, it represents that meaning in a vector. And if you remember your, maybe, if you ever studied this in physics, say, you can think about a vector as, let's think about an analog clock that has a couple of hands on it. Let's focus on the hour and minute hands. First of all, you probably want to make them the same size, so normalize your vectors. But they rotate around the middle axis. And if you have 2 words or phrases that are semantically close, it might be like it's 5 minutes past 12. So they're fairly close together on the clock. If you have things that are unrelated, let's say dog and dog and banana, it wouldn't be like 5 minutes past 12. It might be 25 minutes past 12. They would be somewhat different. and then that's a two-dimensional vector. You can add a third dimension. Maybe you have a hand on the clock that sticks out of the clock, say. That's a three-dimensional space now. And that's another way to distinguish one vector from another. So dog and cat might both stick out in the same manner with, similarly close together vectors. And if we extend the vector thing past that many dimensions, we can no longer really visualize it. And this goes up not just to 2 and 3 dimensions and 4 dimensions, but 3,000 dimensions, 3,072 dimensions. So it's stored as an array of 3,000 plus floats. And but it stores meaning. It's a super powerful concept. And this is how vector databases do their thing. And there are techniques like cosine similarity analysis that that can be used to compare meaning. So I'm going to just very briefly show that. And it's this app here. The similarity analysis is expressed as this floating point number. This number is actually ranges from -1 to 1. And in this histogram is intended to just give you a better visual of it. And so a king and a queen have 0.56 correlation here with cosine similarity analysis. So the vectors are somewhat close to each other, as opposed to let's say hiking, slightly closer than hiking and walking, and much less close than this is an ancient English text. I think compared with the phrase Sesame Street, these are very far apart. These are 0.9, 0.9. And if we use this same text, ancient text, with this is real text, but ancient with nuclear physics, we actually get a negative correlation or negative score. And these are pretty hard to come by. So I had to go to this ancient English text and nuclear physics to get two that were negative. But you can see that like it's actually scoring these and they sort of make sense. And you can also combine them. So a queen and king are 0.56. Queen and king plus woman, this program is actually able to add two vectors together, actually is closer than just queen versus king. This is the power of embeddings, and this is a lot of why your LLM works the way it does. And this is a contribution, I would say, prior to the LLM realm that the AI community has made. All right. This code is available if you want to go look at it. So the embeddings play a key role. They're important for semantic processing, and they rely on tokenization and so forth. Let's jump to a more familiar concept for everybody, which is probably the prompt. This is the thing, the central actor. This is what everybody interfaces with the LLM with, generally speaking. I have 4 sons. I used to coach baseball, including when they're 5 or 6 years old. They play what's called T-ball. You hit the ball off of a tee instead of being pitched, the baseball. And when I first got there as a coach, the coaches who've been doing it for a long time said that the hardest problem they got was they couldn't convince the kids not to throw the bat, no matter how many times they told them. The kids always, half the time or something, they would still throw the bat. So I realized that through prompt engineering, if I told them to put the bat on home plate, they get better results. And this is a cute story from history, my personal history, but I think it's representative of sometimes rephrasing things. This is an interesting part of prompt engineering, and a powerful part sometimes. So a prompt instructs the LLM. Prompts are typically text, but we have more multimodal LLMs becoming more common. You can paste an image in a bunch of LLMs these days, and it will make sense of it, no problem. And the prompt also carries along with it things like RAG, So if you're doing RAG, which is usually means you're looking up extra information, sometimes with a vector database, which uses the embeddings and the semantic understanding that we just talked about, so you get something that is relevant. If you're using RAG, that goes to an external system and brings in a bunch of extra contextual data. And that ends up going into the LLM along with the rest of your prompt. So the prompt is carrying a lot of responsibility here. And your prompt might be a request. Tell me about the book I, Robot. And a semantic search, a RAG-based lookup semantically, might find that the author, who's Isaac Asimov, might become part, even though maybe the book, maybe the expression I, Robot isn't even in some of your understanding. The text isn't in, say, a clip of RAG data that you bring back, because it's semantically relevant because of the author of the book. That is the kind of thing that might come from the semantic lookup done by RAG, placed in the prompt, sent to the LLM. And just to point out, the prompt engineering has lots of aspects to it. We often, the simplest thing we do is a zero shot, but that's just hey, how old is the president of the US, or translate river into Mandarin. Those are zero shot. There's no examples given, but then you can go to one shot and few shot. And then there are more sophisticated approaches, chain of thought, and they're all here. I'm not going to go through them, but the point being that there's a whole literature of ways to manipulate your prompts to get better results. And Semantic Kernel is happy to, you can use all these with Semantic Kernel. It's not limited in any material way. Other prompt execution influencers, I mentioned the contents of the prompt. If you're doing a chatbot, which is in the title of this talk, a chatbot is basically a prompt that returns all the other questions and answers that you've asked so far. So it turns out the LLM itself is stateless. So you have to provide the illusion of state. So if I ask the ChatGPT, say, what are some fun things to do in Athens? It may give me, I might say, give me 5. It might give me 5. And then I say, if I'm visiting Athens in the fall or October, say, do they all still apply? And it will respond. But I don't have to retell it that we're talking about Athens and that it's already given me 5 possible things to do there. That's all sent back programmatically by me or by the programmer in the chat history. So the statefulness is an illusion, but that's more weight that the prompt carries. So the prompt has a lot of work to do. I also mentioned there are limitations to how large a prompt or the number of tokens that can be handled and the interaction can be. That comes into play eventually with chat history if it gets too large. There are also probabilities in the model. These were based on the training of the LLM, kind of like the embeddings with the vectors. And there are 2 key ones: top P and temperature. Top P is a probability, also called nucleus sampling, which says that maybe you have, to simplify it, let's say that you have 100. Actually, I have an example of this in a couple of slides. I'll come back to that, and temperature. And then available tokens, you can specify, this is an influencer, you specify the max tokens in the context window. You specify the max tokens, but you also have to stay under the context window. That's LLM specific. And of course, only one of these would be set, but the typical values or the available values from top P are 0 to 1. Higher numbers are more creative, more words can be considered, and similar temperature goes from 0 to 2, basically. If you go too high, you may get nonsensical results, and lower for, say, precise results with some variability. 0 on either of these, it gives you deterministic behavior, because you're not giving the model any room to be random about which options it chooses. And just to make that more relevant for top P, if I say top P is 0.7, there's a very simplified example, of course. It only goes up to the top 0.7. It's a probability, so all these numbers have to add up to 1. So if I said top P equals 1, it would consider all these values. If I said top P equals 7, it cuts it off at 0.4 plus 0.3. That reaches 0.7. So hey, greetings, salutations, it was up, all get ignored. And then, so only those 2 get considered. And then the temperature takes over. And the temperature is basically a rating of how to choose among these. And they're very close in probability. So these would probably come out, about as you would expect them. If I slammed T to 0, though, I would only get hello. And if I made T closer to 1, say, I would probably get almost 50-50 on these. So those are influences of the outputs, how the LLM behaves. But again, trying to bring this up in the context of semantic kernel. And this stuff is all supported in semantic kernel with these settings, these prompt execution settings that we're revisiting a few times. We saw max tokens. Now we have top P and temperature. Since we're talking about prompts, there's a lot of ways to manage prompts. You can have prompts in your code. It's easy for putting together a demo, say. You can put them in external files. You can put them in a YAML file, and semantic kernel will support that. You can load it from a database if you want. Semantic kernel doesn't care. And there's also this pretty cool library, also from Microsoft, called Prompty, that has a VS Code extension and bindings within semantic kernel itself. So you can load a Prompty file with .prompty extension into semantic kernel to use as a prompt. And it's a little more sophisticated than just the prompt. You can specify top P and temperature and other stuff, max tokens, and the LLM even, if you want to, in a Prompty file. So something to keep in mind. And that's prompts. They're a pretty central actor in the whole LLM conversation, obviously. And a lot of data gets pumped through with the prompt. Okay, so we're getting to the good part here, to the tools and the agent part. So let's do the tools first. So what is a tool? In the context of any LLM, it's actually interesting that if you ask an LLM interactively, you go to ChatGPT and ask it what time it is. At least it used to not know what time it is. I don't know if it knows today, but increasingly they have access to tools in the interactive chat window. So you can ask it what time it is. You can ask it stuff that is sensitive to the current date and time, like is it dark out in Athens right now? Because that, of course, depends on the time, and the LLM knows about Athens, but it just needs to know what time it is to figure that out if it's dark out. So you can give a tool to your LLM, like something as very basic as what time it is. For your company or your business, you may have other things that you want it to do your way. So while an LLM might be able to do calculate a mortgage payment, you might want it to use a certain formula, and you probably are concerned that LLMs aren't the greatest at doing math anyway. What they tend to do is they'll generate some Python code that does the mathematical operation, and then they'll execute it and then use that in their results. But you can control this. So this is another example of a tool. This is through Semantic Kernel that you can give to your LLM. The LLMs, interactive ones, are better and better at this, but still not everybody's the same in that you can ask. I was testing this morning. I asked about the US president. I just said US president. I didn't specify. I didn't tell it what the date was. And it told me about the prior US president, not the current US president. So that's a challenge where the model, that particular model I was interacting with, only knew about the data that was in it when it was trained. And it wasn't trained in the last couple of months, which would have, if it had been trained in the last month, say, it would have known about the current US president. So this is basically a Google search or a Bing search. And so this is a form of RAG, retrieval augmentation, where you're bringing in some relevant information into the conversation. And again, this is a tool that you can give to the LLM, but you don't have to write this tool. The Semantic Kernel and Azure teams have done this, and there's a Google plugin that you can use to do a Google search. So Bing and Google search, they're examples of ones that you don't have to write. You don't have to write the time one either. There already is one, but there isn't a standard calculate mortgage payment one. So if you want, that you gotta write that yourself. You can also read. You can have domain operations that actually read from your company's private systems. When you do a plugin in Semantic Kernel, it's just code. And what can you do with code? Whatever you can do with code, you can do with this code, because it's just code. It speaks through an interface, but behind that interface, it can be whatever you want your code to do. So that can access your inventory system, your financials, your customer support tickets, and so forth. You can access traditional services, like look up a customer's order history, or it could be vectorized, like a vector database, and you can look up semantically relevant stuff. Entirely up to you. This is an open-ended option here. And just to point this out, you can also have it mutate data, save data, add data, create a support ticket, for example. So tools can do things, anything that code can do, and code can create support tickets. So imagine, so this is what it looks like in Semantic Kernel to do to create a function that can be called that uses the Bing web search plugin behind the scenes. As I mentioned, there are also other ones that are kind of off the shelf. Datetime, there are a handful of them. If you want to build a native plugin, you're basically creating a function called, in this case, it's image URL validator function. And you add it into Semantic Kernel, and you give it a name that Semantic Kernel will use to, this is underscore, this is snake case, like Python. The advice from the Semantic Kernel team is that these work better than an arbitrary name. So I follow that pattern. But this basically in my, in the prompt, you can reference the URL validator, or directly, explicitly, or you can have the LLM know it by that name. And just this comment up here: native functions are invoked in proc, within the, or they can be, but not a constraint. It can go off box to resolve the URL. So a URL validator would go do an HTTP call out to the internet, or I guess it could also be your intranet if it's a locally sourced URL, and see if it's really a ping file, or it doesn't really exist. And then you can, as an actual example in the code for the that we're going to execute in a couple minutes, that built up to an agent, agentic powers, also has a feature to describe the image at a URL. That's a native plugin, just like everybody else, just like the URL validator, except because it's code and I can do anything I want, it actually recursively, recursively can be maybe is easily misinterpreted, but it is implemented using another LLM. The main app is implemented using an Azure OpenAI hosted LLM. This function, just to show that you can do that, is actually making its own call out to OpenAI to describe the image. And we'll talk about why you want to describe the image in a minute. So these are built-in, pre-built plugins like the search plugin and the date time, native plugins that you write, your code, and semantic or prompt functions that are based on a prompt, such as from a prompty file. So you can have your function baked into a prompty file, which is a YAML file basically, but with a more elaborate schema for it and more functionality. And it works with the plugin and so forth. Not in this application, but just keep in mind, you can have other kinds of prompts too. They could be in YML files as opposed to a .prompty file, which means something a little bit different. They can mean your code, you load them from your database, whatever you want. They can be over the network, an open API, AKA Swagger 2.0 kind of an interface. So this, you can call remote things, so they can be hosted by other people. And there's an emerging standard called the Model Context Protocol, and this is seems to be getting some traction. So maybe I should add this to the to my my demo here. But so you might want to check that out. And this is what the semantic kernel code looks like when you add tools to your LLM. So I add 4 functions. One is an icon finder, which comes out of a prompty file. One is a URL validator, which is just code, and it has some logging in it, and the logging has 3 asterisks. But the logging just basically does an HTTP GET call, and then it gets an image back. And then if it's, say, a ping file, it tries to check if it's really a ping file, as opposed to an error page or something that that seemed to resolve with a non-404. So you have some confidence that it's a real image. There's a describe image at URL, and the logging there has hashes. And describe image at URL, that's the one I mentioned, internally uses a different LLM just to show that arbitrary code is arbitrary code. Then image web search, this uses the Bing search feature. So this is how you register with your semantic kernel in your C# code additional tools. And however, when you register those tools, they're still only under your control as part of the prompt. So if I want to know if it's dark out in Athens, I can say, it is, and then this stuff. In the LLM, because I've given it the time plugin, this is one that comes from the semantic kernel team, I've given it the time plugin, it can look up the current date and time, and then the LLM knows about Athens, and it can say, oh, yeah, if it's this time UTC, say, I know it's dark or light out or whatever in Athens. So it can do that. So, but the thing here is the LLM is calling these. You're not calling them. You could do string substitution in C# before you invoke the prompt. That's fine. But this approach is asking the LLM to call out to the functions. So your LLM can now use tools, but only when expressly mentioned in the prompts. Still not making any relevant decisions. It's still not agentic. If these aren't embedded, it's not invoking this plugin at all. So let's get to that part of the agent. So the last step in our journey is to create an agent. An agent, I would say a reasonable definition, there's a lot of definitions out there, is it has agency. So it has some degree of control where you give it a goal and ask it to do the work. And there are other things it might have, like maybe it has memory. That's pretty useful for, say, a chatbot if you want it to be stateful. It has tools, probably important for it to do anything meaningful. We showed some of the functions that and plugins we registered for this. And the key is when it's in an agent mode, the agent is deciding which of these functions to call, in what order. Maybe it retries some. It decides this though, and you've given it a goal, but it figures out how to execute that goal using the tools and you've given it and the instructions. So this is some excerpts from a prompt. Prompt is in code; it's not in the prompty file, but I'm basically telling the LLM, I'm giving it a goal. Say, get a valid URL for the logo of, and we'll give it some more information. I'm going to do it for a technology brand like Python or the GNU project, say. And there's more information in here, but you can also tell things like, if you encounter errors, do some retries. Don't just give up. And so I'm encouraging this thing to grind until it figures it out. Note that I'm not telling it to call this tool. It's doing a semantic association between, well, my prompt asks me to come up with a valid URL, and it has a URL that, it has a function, a plugin that knows how to validate a URL. It also has a function that knows how to take take an image at a URL. If it's already, it's going to determine probably that it needs to validate it first. It also takes an image at a URL and it will describe it. So for example, the Python logo is two intertwined snakes or pythons, I believe. And if you're creating an HTML page, say, for that you want to be more accessible for a screen reader, you might want to describe what that image looks like. And that's what this this agent does. It will, you give it the brand like Python, it will find URLs for the logo. It will make sure that they're actually really URLs for the Python logo. And then it will produce an HTML snippet that includes a description of what the logo looks like, a reference to the logo, and an alt tag that says this is the Python logo. So not just it's the Python logo, but it's two snakes, that kind of thing. And this is the semantic kernel call to invoke a prompt by hand. And so this is the, so we've already been showing the prompt execution settings. And this is showing one more setting. And this is telling the LLM to go into auto planning mode. And hey, LLM, I'm going to give you a mission. This prompt here, this, hey, the stuff I just described as an example. And I want you to figure out, of the functions and the tools that I've given you, which ones to call to make it happen. And, of course, we can also set max tokens, top P, temperature, and so forth. And this execution settings value gets passed in with to the LLM along with all the prompt data. Okay, so let's look at it. Let's see. Okay, so if I run it, this is just a console app, and it's looking for a brand. So we'll give it the brand Python. So we've got a bunch of logging in it, including a bunch of stuff from OpenTelemetry. And getting started. It's using the Bing plugin. And Dun, dun, dun. So it's come up with a URL at this address, and according to my URL validator, it failed. There isn't really a logo there. It looks like it's 404. So this is the agent doing its work. A lot of logging, and it's got a different logo here, and this one passed, and it is a ping file. And so the agent continues, and then it's coming up with a description. The image depicts the logo of a Python, a graphic of two intertwined snakes. Nice, okay. And then it outputs, and this is the final output. Like if we had no logging, we would just get this line, which is a snippet that I can put in my HTML page that tells exactly what if this is, say, a user who can't see, this is being truncated, let me. Oops, okay, there we go. Yeah, sorry, this is a little too large. So this is the output at the end here. This is a description of the logo. This is the alt text that says it's the Python logo, and this is a link to the logo. So this I could bash into my HTML file and I'd be done. So the agent did some work for me. It saved me from a Google search or Bing search and finding the image and coming up with a description of it myself. So that's the agent is referenced. Everything will be blog.codingoutloud.com. So there'll be a page. I'll probably do that in the next day or so. I'll blog about this talk. I'll have a reference to where you can find all the code and the slides, and that's it. And if anybody has any questions, I will take them. So I'm trying to see. I am not 100% sure how to see questions.
Hello, everyone. Thank you, my friend Bill, for this exciting presentation. I will tell you the truth. It's the most technical one I have seen in our event series, and it clearly shows how deep is your expertise and your technical capabilities. And I really like the way that you presented it to us. Like you broken down the steps. We went very deep, and even for someone who is just starting, things were quite clear, at least for me who are not a developer. Thank you so much for this amazing presentation. I don't see any comments like questions or anything else. Bill, I will once again say how grateful I am that you were able to present in our event. Hopefully we will see you again in another event of ours. Have a great one, and bye-bye, my friend.
Very good. Thank you. Glad to be here.
Bye-bye. Great. Amazing presentations. We have our next speaker already in the queue. Now we have with us Georgie Talakshvili, if I am pronouncing correctly. Georgie will explain to us his session about supercharged search with semantic search and vector embeddings. One of the most interesting technologies for me. I'm very deeply engaged into semantic search and vector embeddings. In fact, I have spent so many nights trying to understand, figure out the technology behind it, especially on Azure AI Search, integrating into our web apps. I'm so happy that Georgie here to explain more on this as our expert. Let me bring Georgie on the stage. Hello, my friend. Welcome to Azure
Hello.
AI Connect. We are
Thank
so
you
grateful
for
that you are able to deliver this session for us. I will be on the backstage. You can bring your screen so I can add it to the stage, and I will shut up now and let you deliver your session, my friend.
Hello, everybody. Today I will be talking about semantic search and vector embeddings and how to implement it with Azure SQL database. First of all, a little bit introduction about me. My name is Georgie Talak. I'm a software architect at Space International. I have 16 years of experience working with C# and .NET ecosystem, and also with SQL Server and Postgres database. You can follow me on my GitHub and check out my open source projects. If you use Entity Framework in your job, I think you will find my projects interesting. I'm also a Microsoft MVP, so I'm happy to share my knowledge and experience with you. So let's start. Today I will talk about semantic search, vector embeddings, and vector databases. In this case, I will talk about Azure SQL database. So what is semantic search and what makes it different from the ordinary search, which is called lexical search? In case of lexical search, the results that the users get back is it matches exactly the words that the user enters, or sometimes derived words. But in case of semantic search, the returned results are matched based on the meaning of the words and may or may not contain the exact terms that the user entered. For example, if the user searches for learning how to use a database, one of the searches can be SQL crash course, which does not contain any of the query terms that the user entered, but matches on the meaning of the query that the user entered. So what are the benefits of semantic search? The benefits, there are multiple benefits. One of them is that it can distinguish between meanings. For example, if we have chocolate milk and milk chocolate, we as a human can understand that milk chocolate refers to a variety of chocolate, whereas chocolate milk is a chocolate flavored milk. So the semantic search can distinguish between these two terms and return relevant results based on which ones the user entered. Also, users don't need to remember the exact terms and names that you have used in the names of your items or in your database. They can just enter the idea of what they are searching, and they will get the meaningful results back. And the user interaction is more human and makes the experience more similar to the human interaction. Like when you go to the shop, you may not ask for the exact name of the item, but you describe to the consultant what you need, and they offer the matching items that matches your description. It's same in this case of semantic search. Semantics. Let's see how semantic search works. It is built on top of three main concepts. It's LLMs, known large language models, embeddings, and similarity metrics. So let's start with LLMs. Large language models, they are trained on vast amounts of text data. They can understand the context between words and the relationships between these words. Once we have these large language models, we generate embeddings, also called vector embeddings, for the data that we have in the database, and the embeddings encapsulate the semantic meaning of the data that they describe. Basically, the embeddings map the textual data or data in any other format to a high-dimensional space where items with meaning closer to each other are closer to each other as a vectors. And similarity metrics is the instrument that allows us to measure how similar two different vectors are. We can determine the relevance of the search results by comparing the embeddings of the query terms that the user entered to the embeddings of the documents that we have in the search index. So let's talk about a little bit more about vector embeddings. They are a numerical representation of the data, and the key idea between vector embeddings is that two pieces of information that are closer to each other in meaning, they have vector embeddings that are close to each other in the space. So basically, they represent the meaning and context of the data that we passed to the model, and the LLM processed the data and gave us back the vector embedding. In this illustration, you can see that, for example, different animals are close to each other because all of them are animals. They represent different animals. Fruits are also close to each other because all of them are related to each other, but animals and fruits are apart from each other because animals and fruits are not related to each other. Vector embeddings have many applications. Semantic search is one of them that I will talk about today, but they are also used in text classification, anomaly detection, recommendation system, and they have many other use cases. Basically, vector embeddings are a way to convert words and sentences and other data into numbers that capture the meaning and relationships between these words and sentences and so on. We can think of embeddings as a coordinates in a multi-dimensional space. So here we have a three-dimensional space, but large language models generate vectors that have very big dimension, hundreds and sometimes thousands of dimensions. We can think of vector embeddings as a supermarket. In supermarket, you would expect apples and bananas to be near to each other because both of them are fruit. But if you are looking for a magazine or something else, then you will go to a different part of the section because you don't expect to find magazines in the same section where fruits are sold. So how exactly semantic search works? first of all, we have here the documents. They can be text, it can be text data, it can be image, it can be video or audio. We have an embedding generator. We generate embeddings for the data where the user will be searching, and we get vectors, as I said. We will store the generated vectors in the database, in some vector store. When the user enters the query term, we again generate the embedding for the query term, and then we search in the vector store for the items that have we search in the vector store for the items that have embedding which is close to the embedding of the search query, and we get the search results. The important thing is to use the same model in both parts of the process. So when we generate embeddings for our data with one of the models, we must use the same model to generate the embedding for the query term. Otherwise, we won't get any meaningful results. It's like searching for a French text in a English dictionary. Obviously, you can't find anything because they are in different languages. It's the same here. You must use the same large language model for generating the embeddings of the data that you have and for generating the embedding of the query terms that the user enters. Now let's discuss similarity metrics. So how can we compare these vectors, and how can we decide whether two vectors are similar and close to each other or apart from each other? So in this case, the blue dots illustrate the items in our database, and the orange dot is the query term. And we can see here that we can see which items are close to the query term. So in a two-dimensional space, we could calculate the distance between the orange point and the blue points using this formula, which is really simple. You don't need to memorize this because it's already built in SQL Server and other vector databases, but I just wanted to show it for demonstration to understand what the distance means when talking about vectors. And if we have a multi-dimensional vector, like hundreds or thousands, we can just use this formula, but instead of two terms here, we will have multiple terms, and the same formula will also work. So similarity metric basically is a function that takes two vectors as an input and calculates the distance between them. And we can use the similarity metric to judge how close or how far apart the two vector embeddings are. There are different similarity metrics. We will see it on the next slide. There is no one-size-fits-all distance metric. They have different speed and different accuracy, but the best practice is to use the similarity metric that is used by the large language model itself. So these are the most common similarity metrics. We saw the Euclidean distance on the previous slide. There is also cosine similarity and dot product. They have different meaning, and they consider different properties of the vector when calculating the similarity metric. So you don't need to memorize this, just know that there are different similarity metrics, and you can choose the one that is used by the LLM that you use to generate the embeddings. So how do we generate the embeddings? There are multiple options. One option is to use a third-party API like OpenAI API or Azure OpenAI. OpenAI API. You can also use Hugging Face API, which hosts different models, and you can choose which model do you want to use. And another option is to run the model locally and generate the embeddings locally by running the model. You can do it from .NET. You can do it with Python, depending which language you use. There are different libraries, and also there are other libraries for other languages. If you decide to use a third-party API, you can call this API from your application code and insert the resulting embedding together with your data, or you can, in case of a SQL Server, you can invoke the Azure OpenAI directly from Azure SQL database and generate the embeddings after the data is inserted in the database by making the corresponding API calls. So once you generate the vector embeddings, you need to store them in some kind of vector store. So there are different solutions for this. We can divide them in three different types of databases. One is specialized vector databases, which are specialized databases designed to store just the vector embeddings. There are multiple vector databases out there like Chrome, Qdrant, and so on. We can store vector embeddings in relational databases. All the major relational databases support vector embeddings. You can store them in Azure SQL database. It is in public preview and will be released later this year, I guess. It will also be available in SQL Server 2025. It's available in Postgres, both in Azure and on-premise, and it's also available in Oracle 23 AI. And also the other NoSQL databases, such as Azure Cosmos DB or Redis, MongoDB, and so on, they also support storing vector embeddings and working with the vector data types. So in today's presentation, I will talk about vector data support in Azure SQL database. As I said, it's currently in public preview, so you can check it out on Azure already and explore how it works. The implementation in Azure SQL database provides support for exact and approximate nearest neighbor search. It supports different similarity metrics that I have mentioned, like cosine distance, Euclidean distance, and so on. It also will support indexing the vectors, and also we obviously will have all the features of SQL Server. So why use Azure SQL for storing vectors? It's easy. First of all, if you already have Azure SQL, you store your vectors with the rest of your data. You get all the operational advantages, like when you create a backup, all the embeddings will be included in the backup. You don't need to synchronize between your relational database and other database. It's an ACID database. It has you get all the benefits that you get with Azure SQL database already. It's fast, it's cost effective, and all the client libraries that are out there for working with Azure, they can already work with vector type, because client applications can work with vector data as if it was a JSON array. The vector type itself is stored as optimized binary, but you can work with it as a JSON array for from C#, Python, or Entity Framework Core, and we will see a demo of it later today. So you use the vector type like you would use any other type in the database. Here we can see the create table script. We have a 3-dimensional vector. We insert in the table this is the same way as you would insert any other data in the database, and you can see that the embeddings that are inserted here, we can refer to it as a similar to the JSON array of numbers. As I said, they are stored in optimized binary format, but are exposed as JSON array for convenience. We also have the vector distance function, which calculates the distance between two vectors using the specified metric. In this case, it's calculating the vector distance with cosine similarity. It calculates the distance between the embedding column and the target vectors that we have declared here. And we can also use it in order by, so we will get the results which are more similar to the target vector, or if we want to display the similarity metric, we can also include it in the select statement, and we will see the actual distance between the target and the embedding data that we have in the database. So let's see a couple of demos. Here I have a database of news items. It contains news items from couple of years. We can see the date here. We have the headline here. Every item has a headline, and we have the embedding data column. You can see it's shown as an array of numbers, and this embedding represents it is the vector embedding of the headline column. So for every item, I took the headline and calculated the vector embedding using the OpenAI API and inserted it in the database together with the data. Let's take this example here. We have a query where we get the embedding data from the news item table, and we get the embedding for this single item where the headline is, in this case, the flight that disappeared. So the variable here will hold the vector embedding of this headline, because the embedding data holds the vector embedding of headline column. Once we get the vector embedding for this item, we find the top 10 items in the table, and we calculate the distance between the vector embedding of this variable and the embedding data column. We give it a name distance and order our search results with distance. So when we run this query, we will get top 10 items from database which are closest to this item. So if I run this query now, you will see that the first result is this item itself, because the distance in this case is 0. It matches exactly because it's the same item itself. And we get 9 more results here because we asked for top 10, and we can see here the results. The lower the number, the less the distance between the embedding here and the embedding stored in the database. So it means that this item is more related to the text here than the last item here. So we can see that we can search the data with the vector embedding, and we get results that are close to the data we have basically by understanding the semantic meaning behind this query term and behind the headline that is stored in the embedding data column. Now let's talk about vector indexes. In the query that you saw now, we were searching with the using the KNN, which returns an k nearest neighbors. KNN is computationally very expensive because it has to compare every item in the database to the query terms that you entered. So a solution is to use an approximate nearest neighbor, which gives you approximate results. So not the exact results, but it's much faster with the exact results. The time to find the search results increases computationally as the data increases linearly, but in case of ANN, as the number of elements increases, the search time increases logarithmically, so it's a lot faster than KNN, and it trades very small bit of accuracy for a very big gain in performance. ANN algorithms enable much faster queries by approximating the nearest neighbor, and they do this by exploring a subset of the data sets, and it reduces the computational burden on the database server. So as I said, approximate nearest neighbor finds similar vectors without searching all of them, and it offers significant computational efficiency. But because we don't get the exact results, we have to come up with a way to assess how good the results that we got are compared to the exact matches. And we can do it by calculating recall. Recall is how many retrieved neighbors are the true nearest neighbors. So in this case, we have a search query, which is red, and we have 5 items in the gray area that are the 5 nearest items. If our approximate nearest neighbor search returns the 5 items that are in the orange section, then the intersection of the orange section and the gray section is these 4 items that appear in both of them. So these and these 2 are 4 items that are part of the gray area as well as part of the orange area. So in this case, we can say that recall is 80% because we got 4 matches out of the 5 nearest matches. So 4 out of 5 is 80%. So in this case, recall is 80%. So usually when using ANN algorithms, the recall that you get is 95, maybe even 99%. So you don't get bad results, like you get 95% of the true matches or 99% of the true matches. So it's pretty near to the exact neighbor, to the exact nearest neighbors. So the computational trade-off is usually acceptable for the little bit of trade-off in the accuracy. There are different algorithms for ANN. there is inverted file with flat compression. There is hierarchical navigable small world. These two algorithms are very popular in Postgres. There is also disk ANN, which is also already available in Azure Cosmos DB and Azure Database for Postgres, and it will be available in Azure SQL Database. Currently, it's in private preview, so I can't, I don't have access, and obviously I can't show or talk about it. But if you are interested in this ANN, you can check out the docs for Azure Cosmos DB, and I guess it will be similar for SQL database. It was developed by Microsoft Research. It provides high recall, high throughput, and low query latency. It can surpass HNSW and IVF flat in latency and accuracy. And as I said, it's already available in Azure Cosmos DB and Azure Database for Postgres, and it's open source on GitHub. Let's see a couple of demos. I have a console application here written in C#. It's connected to the Azure database that I showed earlier. And there are two databases. One which does not use vector filtering, and so does all the calculations in memory, and it's also connected to the Azure database to filter the items in database. So if I enter a query term like this, plain that we can see that it took about 2 seconds to search in Azure, which is not bad considering that the database is on the other side of the world. And here we get the results. We can see different news items returned from the database. The score in this case, it shows the higher the better. Basically, it's if you subtract this score from 1, you will get the distance. So in this case, higher is better. The lower the distance, the higher the score between the search term and the item in the database. And if we view the query for this, if we use the SQL query for this search, here I have declared the vector. OpenAI generates vector embeddings which have a dimension of 1536. So this is a big vector. It represents the query terms that I entered, planes that disappeared. And here is the query itself. We get the distance, and also we order by the items by distance. So if I execute this, we will see here the matches, different headlines that match the phrase plane that disappeared. Here is the distance, as I said, so the lower the better, and they are sorted by the distance in ascending. So the items at the start are better matches, and the items at the end are farther apart. You can also try entering another query term. For example, if I search for volcano disrupting flights, we get here now in half a second, we get the news items about the eruption. So it was causing flight delays. So as we can see, even though some of the results here don't contain the exact words that I entered, we still get meaningful matches. And as I said, its vector data type can integrate with C# libraries with entity framework, so it's very easy to use vector embeddings from C# and entity framework. We can just call the vector distance function, and it will be translated to the vector distance database function call. The benefit is that the filtering is done in the database side, and we don't have to pull all the records to the application and do any filtering in the application. We just get the top 10 results that are closest to the query term in the meaning. So this completes the presentation, and you can check out the demo at GitHub and follow me on GitHub or on Blue Sky. And if you have any questions, I'm ready to answer them.
Thank you, Georgie. I'm sorry, that was an amazing presentation by Georgie. Very deep level, especially on the technical aspects and the use of Visual Studio. I don't see any questions currently. You can follow Georgie on the links that you can see on his last slide. What I have to say is that I'm following very closely the developers that are working on search applications, vector search and semantic search. This was a very interesting and insightful presentation. I'm going to watch it later again, in my own time to get a better understanding. And I will stay connected with you, Georgie. We have now an initial channel of communication. I want to say a big thank you for delivering this demo, this presentation, and we hope that we will see you in another event of ours if you have the time and the capacity to deliver another session on us.
Sure, thank you.
Thank you very much. Georgie was the last speaker for our Room 1 on Thursday, 13th of March, day 4 of Azure AI Connect. See you tomorrow, guys, and have a good day, good night, and good afternoon, wherever you are. Many thanks, Georgie. Bye-bye, my friend.
Bye.